Hello, I'd like to welcome you to this course in MySQL. We're going to be working with the software, seeing results, and working with the actual MySQL database itself. What is SQL? Now you notice that I'm pronouncing it that way, SQL. That is a common way to pronounce SQL. SQL, spelled out like that. So it's an abbreviation for something called Structured Query Language. That's not something you need to think deeply about, but that's what it originally was called. And here's what's key. SQL, and by its extension, MySQL, is a unified language for defining database objects, for querying, for getting information out of data, seeing it, manipulating it, getting it the way you want to see it. It's also used for modifying data, for adding, deleting information, for adding, deleting objects out of the database. It's used for security, controlling the data, controlling access to data. The key thing here is this is for a relational database. And we're going to go into what that is in a couple of lessons from now. I'm going to go into detail about what makes something a relational database. Suffice it to say, all major databases in the industry today are relational databases, and they've been around for a couple decades, so they're not going anywhere. Some people, when they hear the word SQL, they think that it's actually software. There are implementations of SQL, but SQL is actually a standard. It's a specification. It was developed originally by Dr. E.F. Codd at IBM Laboratories. This whole system of dealing with a relational database and using this unified code called SQL to be able to deal with that relational database. So it all came out of IBM Labs back in the early 70s. Commercial institutions, they now lead this standard by extending SQL and MySQL to meet the needs of business. So what this means is, even though there's many different commercial relational database management systems, or DBMS, in the industry today, like Oracle, Sybase, Microsoft, IBM, and MySQL, they all implement this standard in their own special way. 85–90% of it is the same. If you know one SQL, you know them all. There are differences, and they're important to know if you go from one to another working in an organization. I'm going to focus on MySQL, but learning that will give you a great base to extend to any other vendor's SQL implementation. In this course, we are going to be working interactively with SQL. You're going to be presented with a page. You can type in a statement like you see here. It says select star from publisher, click a button, and see the results down at the bottom. So we're going to be working with software like that. SQL can also be run inside of computer programs, but we're not going to cover that here. I would dare say most SQL eventually ends up in a computer program application or used with a tool that's a SQL report writing tool like Crystal Reports or ReportSmith. Here, just to get the basics, you're going to learn working with it in an interactive basis. The SQL language itself, and hence MySQL, it's not a natural language. You're not going to say, oh, hey, could you give me the last names and first names of all the authors? You're not going to talk like that. It has a structure. It's not procedural. It's not like a language like PHP or Python or something where you have to order the steps and specify what steps are needed to get the data out of the database and show it to me. You will learn statements. It has a definite syntax. There's rules you have to follow. But these statements will then be sent to the database server and it will figure out how to do what you've requested. So it's not a procedural programming language. It's somewhat free form, but there are individual clauses inside certain statements that have to be in the proper order. SQL itself may not be able to do everything you want to do in one statement, and that's okay. It's not designed to do everything in one statement. Often there's a series of statements that need to be run to perhaps get the data that you are looking for. People do use, like I said, report writing tools like Crystal Reports or custom-built computer applications to format data and present it in a way that they would like. What you see here is sort of a layout of a very simple database that we're going to be using. I will describe this more when we get into the talk on what is a relational database. And this ends your welcome to class. This lesson is on what is a relational database. What you're looking at here is a database diagram of a simple database that we're going to use in this class. It's sort of a book publishing database. Sometimes I just call it the book pub database. And this is just a representation of what goes into a database. Each square box represents something called a table. All data in a relational database is represented in a table with rows and columns. They're regular and it looks very much like a spreadsheet. So I'm going to leave this diagram for a second and I'm going to show you a spreadsheet and then the differences. Here is an actual Excel spreadsheet and I've copied some data in here that represents authors in our publishing database. Over here is a set of social security numbers, then the author's last name, first name, phone number, address information over here. You'll notice by default, you do not have any column headings that are meaningful. We have A, B, C, D. That's by default. And along the left side, we have row numbers that just come by default. We could insert a row above this and label these and put a text heading, and we could even insert a column and put numbers if we needed to, but most people just use the row numbers in the spreadsheet. This grid-like format is what is true for a relational database table, but the way it works is significantly different, and I'm going to go over that now and show you a little bit of an example. As I go through these first two lessons, I'm going to be showing you statements and results that I'm not expecting you to learn yet. We're going to go through them in detail throughout this class. For right now, you're just getting some quick exposure to some of the kinds of things that we're going to do. So this is a SQL statement, a MySQL statement that says, give me everything in the author table. So I submit it, and I get another grid-like return. So I can see here that I have author ID, social security number, last name, first name, phone, the same kind of stuff I had in the spreadsheet, except I have a special ID over here to keep track of each row. Instead of 1, 2, 3, 4, I have a special 3-digit code. This column here, that's what they're called. That's the name of the column. It's called a primary key of this table. And that means it's the column that's going to be used to uniquely identify a row of information. So that's something we had to add. To the right, it looks very similar to a spreadsheet. I have these colors here just in HTML so you can more easily read the table. The logical representation of the data, like I showed you here and in the database diagram, this is the author table we were just looking at. The author ID is the primary key, and these are the various columns of information that we're keeping here. It's just running down, social, last name, first, etc. And the results of the table, it's running horizontal. This is a table of authors. It's the author table, and one row in the table is one author. Even though logically we can see that this is the way the data is represented, for those of you who have done programming before, we don't have to do anything to manage how something's stored. We don't have to say it's in a special file name at a special location on a hard drive. The database management system takes care of that. We will give this table a name, and in this case, we've already done it. This is called the author table. But beyond that, everything is managed by the database management server. And as I mentioned earlier, that there is one high-level language that deals with this relational data. It's called SQL. In this case, we're learning the MySQL brand of SQL. And it's going to allow us to search for data, to query the database, to add new information, to change information that's already there, and delete and remove information. And these tables, like author, we'll learn how to create them, and we'll also learn how to get them out of our database altogether if we need to do that. One thing that makes something a relational database is it allows us to look at information by a column or by the row itself. I'm going to pick another table here. It's called the book table. I have the ISBN number as the primary key for the book, and I have the book title, type, and price, and this sort of thing. So I can limit this by just saying, oh, I want to see the title, comma, and its type. And so I can do that, and I only get that information back. I can also limit this by saying that I only want to see a certain number of rows. Here, I had 16 rows. I might not want to see all the rows. I might just want to see where the type of the book is equal to computer type books. Run it, and now we've extracted a smaller subset from the table. This is roughly called selection and projection. There's also the ability to pull information back together. Let's look at one other table really quickly, the publisher table. And now we'll run it. So we get the whole publisher table. One other key thing about a relational database is the ability to join stuff together, to join tables together. So I'm going to put the publisher name and the title of a book. So far, I'm only looking at the publisher table, but I can join the information to the book table, and I can use a column that they have in column. That is the publisher ID. That's a little number here that keeps track of publisher. So if I do that much and I run the statement, we've taken data from the publisher table, this publisher name, and a book that they published, and that's from the book table. This is an important concept in a relational database. We have to look at these tables and have a way to pull information from more than one of these tables and pull together in a single query on the database. The other thing that it supports is something called nulls. So I'm going to go back to the book table. If we go down here a little ways, we see that there's a little word here called null in some of the columns, in the type, the price, advance, so forth. And what that means basically is no data has been inserted yet into the database. The select statement you've been seeing me use does give a special way to pull back the null values, and you can see where rows have null values. So this is very important. So this is the basics of what makes a relational database. You will often hear the term entity. And this database diagram represents tables, but conceptually they're entities. These are things we want to keep track of. I want to keep track of authors, of books, of publishers, etc. So conceptually they're entities, and when people design a little database, they think in those terms. And then those entities most likely end up one for one becoming tables in the database. That gives it a table name, and we have properties of the table, the characteristics of an author that we want to keep track of, the last name, first name, etc. So there are another set of statements that we're going to use other than a select statement. There's ways to get data into the database with an insert statement. We can change data that's already there. I could change the type of cooking to be type food or something if I wanted to. I could update data that's there with an update statement. And I can delete whole rows, like delete row where the ISBN number equals that. So we'll be going through the details of that. Another set of statements that we'll be using are the create and drop. So we can drop, get rid of whole tables, and we can also create them. And we'll be going through the details. With SQL and a relational database, there are other statements that can handle things like security and transaction control. We won't be going through them in this short class, but SQL will allow you to do that with a relational database as well. This lesson is on what is MySQL. And what I'm going to do here is I'm going to give you a whirlwind tour of running some MySQL statements that involve creating and dropping tables, selecting from tables, adding data, deleting data, joining some tables together. And I'm just going to go through these statements one at a time. You're not expected to have learned them from just watching it this one time. This gives you kind of an overview of where we're heading. It'll be the first time you see the statements, and then as we proceed through the course, there'll be detailed lessons on each one of these statements. So don't worry if something comes across here that you don't understand. So the first statement is the create table statement. It's how we get information into the database. We create the table structure so that we can add data to it. When a table is created, there is no data in it. So we're going to do this. You see I have a column name specified, what kind of data goes in them, whether they're numeric, whether they're character data, or if it's a date column. We have the primary key specified. Not null basically means it is required. You must enter data when you add the row. These null columns don't have to be added in at the initial time a row is added. So right now, I'm going to create the structure. I hit the submit button, and it just comes back and says it was successful. Now I can just quickly try to do a select against it. A select gets us information. There should be nothing in the table now, so I click that button, and all we see are the column headings. Those are basically the names of the columns. But there's no results. Number of rows in results is 0, and that is correct. Nothing has been added yet. So we're going to add something with an insert statement. Clear the box. I'm going to insert into that employee table, and then I have to say what columns I want to insert in. In this case, I'm inserting into all of them. So I've listed them all out by column name, and then a values word, and then these things have to match up. So I'm going to put 1 in the employee ID, Smith into the last name, John into the first name, so forth. And the date is done in this format, 4-character year, month, and day for the hire date. So let's run that statement. Says it was successful. Good. I'm going to grab 2 more of these before we go check it. I'm going to actually put them both in here at once. First one adds employee 2, Perry Steve, different hire date, and then another one for Jane Jones. So I'll enter these in there. How do we know they're there? Let's clear it. We're going to do another select. So I'll pull that in, select everything. That's what the star means, from employee. So now we see we have employee ID 1, Smith, John, Perry, Steve, Jane Jones. Okay. And all this various information. Notice that John is in department 123, as is Steve. Jane is in another department, 234. We're going to use that information later to join all this stuff back together. And you can see the salaries here and the hire dates. Another thing we can do is we can just limit how much of the data we want to see. I'll go in here and I'll put in a new statement, and I don't want to see all the columns. I don't want to see the employee ID. I'll run it again, and notice I had something here called order by last name. So now it's an alphabetical order by last name. So that's the order by clause. Now I'll introduce you to the update statement. This is the statement that's going to change something that's already there. I'm going to give John Smith a raise. So I'm going to copy over that. I'm going to say update the employee table, set the salary to 95,000, but where employee ID is 1. We don't see that here, but when we saw that there before, I know that John Smith was number 1. Let's go ahead and run that. It said it was successful. And now we'll go ahead and I'll show you that with the employee ID again. We'll pull that in and run it. And you can see there's the employee ID, John Smith, and lo and behold, he used to have $90,000. Now he's getting $95,000. So now I'm going to create another table, just a department table. It has a department code as a numeric primary key and a department name, the name of the department. I'll create the object. It says it already exists. When you get an error like that, one thing you can do is you drop the table. That gets rid of the table entirely. And then I'll bring back that create statement and run it. There we go, we get success. So I recreated the table. I'm now going to clear the box and I'm going to insert 2 things into it. I'm going to give it department code and department name, insert into department. 123 is the payroll department. Code 234 is the accounting department. So it's 2 insert statements that I'm running. Let's go select from the department and see what it looks like. Select everything from the department table, and you see department code and payroll and accounting. So what I'm leading here is I now want to join information together. I want to see my employees and what department they're in. The way that's done is we're going to list the department name, the last name, and first name. This is just a little bit of the information, not all of it, but the department name's in the department table. I join it with the employee table you've seen, and that's where I grab the last name and first name. And I use the department code because that's a column in common with both tables. So I'll use those values to connect these tables or join these tables together. And then I'm going to order by department name and last name, first name, so on. Let's run this. And so we see in accounting, we have Jane Jones, and payroll, we have Steve and John Smith. So you need to get that information back together through the joining operation. So now we're going to decide that I've left the company, employee ID 2, so Steve's left the company. I'll run that. We'll go ahead and look at the employee table again and see if that data's gone away. We no longer have Steve Perry, employee ID 1 and 3, but not employee ID 2. So last but not least, I'm going to drop, which is a way we get rid of the table, and I'll drop the table. It does drop it. If I want to know that it's been dropped, one thing I can try is to do a select against it. And this should be an error because there's no longer an employee table. So I hit the submit statement and I get an error that this table does not exist. Okay, there's your whirlwind tour of MySQL statements. Like I said, all of those and some additional statements we're going to take time with and go through it very slowly. Each one of those statements will be a lesson in itself, and we'll go through it slowly and in detail. This lesson is on installing a local implementation of MySQL. But before I show you that, I'm just going to show you very quickly how you can find a hosting service that you can rent, and that can be a very convenient way to deal with this as well. So I typed in web hosting service in Google, and I'll scroll down here to the reviews by PC Mag. And there's a whole bunch of services here that they like. I'll just look at the HostGator one here to get you started. I'll click on the web hosting link. We've got this, and down below I'll do compare all plans. So you can see for about $4 a month, you can get in and get started. Now what this is going to show on the left, there's a whole lot of things that come with it, but I'm going to go all the way down. You're going to get PHP language and Perl and Python and all these other languages, plus you get databases with a MySQL. Down near the end here, you're going to see PHP MyAdmin. That's a service and a tool that we're going to use. I'm going to show you how to install a local version of PHP MyAdmin. But if you want to get a web hosting service, you can do it this way. Go to one of those companies and pay them a few bucks a month, and you can put your database and website up on the internet for all to see. For a local installation, you've got two basic choices. If you're Windows, you're going to install the WAMP server. That stands for Windows Apache PHP MySQL. If you're on a Macintosh, you want to install MAMP, Macintosh Apache MySQL PHP. There's various downloads here for you to deal with MAMP. Just follow the download instructions. You go down here and it tells you which one to install, or over here and download. On both of these sites, it's fairly straightforward. Once you have the server installed, I'm going to show you on a Windows machine here. You'll have some things available to you. And if we look over here, I've done a little screen printing and pasted it onto this web page so you could see it. Over in Windows, you have the start bar, and you'd open that and you'd open up all programs. After it's installed, you navigate down to WAMP server 64 if you have a 64-bit machine, otherwise 32. Uninstall. This gives you some information on the web, but what you need to do is click on this, WAMP server 64. Then you wait a minute, you're going to look in the little taskbar down at the bottom of your window, and you're going to see an icon with a W like that. It'll start out being red, then it will turn to orange after a few seconds, and then when it turns to green, that means the WAMP server is running for you. So you just click on it, and this little pop-up menu will show up. So there's things you can do directly with Apache MySQL and PHP, but where you want to go is here, PHP MyAdmin. And let me show you what that looks like when you click on that. We're brought into a welcome window, and for a local install of WAMP or MAMP, the username is root and the password is left blank. If you override that for any reason, then remember your username and password. I'm going to just accept the default and click Go. Now, once you're in here, there'll be some databases that are already there, and I don't recommend that you use them for your testing. So click on New, and then you just come over here and create some database name. I'm going to do MySQL test, just to make it clear that that's what I'm doing. I'm testing things out. And I click the Create button. So now we have a MySQL test under this other database here. We click on it, make sure we're there. Then we want to go to the SQL window. Now we're going to navigate to a file that has all the SQL you need to create the tables and put in the data to load the test database that we're using in this course. So I went over to this file. In your working files in chapter 2, it'll be MySQL reload bookpub.sql. That's the extension. So what I recommend you do is you just select all that text and then copy it. You can do it from here if you want, copy it, and then go back to the PHP MyAdmin window. So what we do here is we go and we paste that in, and it puts in all this code, 288 lines almost. So to get it to run, you go down here and you click on the Go button. It just says one row affected, which is a little bit weird. So click on the MySQL test again, and you'll see that you have all these tables here. You have an author table, MySQL test again. Let's go back to the book table, because I showed you this in the very early introduction to MySQL. I showed you some of these tables. Unlike that presentation tool I used, Here you see the data over to the right of these buttons. So you can work with these buttons to delete and edit the data directly, but I'm teaching you the SQL to do that, so you want to practice doing that. So what you do is anytime you want to run a SQL statement, you click on the SQL tab. And then like we had earlier, select star from, and I'll do author. To run it, you don't use these buttons. You go down here and you click go. And now I see all the data for the author table. So this looks a little different than the interface I used to present it to you, but the interface I used made the text a lot easier for you to see. You, though, can take all of that code and just run it in the SQL tab and put it there when you want to practice. This PHP MyAdmin tool is wonderful. All the hosting services will have it, and this is your local installation. Feel free to run things, play around with it, delete data. If you really mess things up, you just copy back that SQL statements in that I gave you in this test file, MySQL reload, bookpub. Just copy them in, run them again, and everything will get reset. This lesson is on creating and removing tables from the database. Now, as I mentioned in an earlier lesson, we're going to be using a test database that I call bookpub for book publishing. And there are a few tables that are already loaded. We have tables like to track authors and books, relationships between books and authors. And I'm using the PHP MyAdmin interface that I told you about. Here, with the author selected, we can see that there's data in the table already. The data kind of starts here with the author ID column, and then it goes over to the right. These fields over here to the left are just something to use with PHP MyAdmin. Now we can create and delete tables within this PHP MyAdmin interface, but I'm going to show you how to do it with SQL. So instead of using this interface, which is a little bit harder to follow where we type in the select statements here, I'm going to use a different demonstration tool. But everything that I show you in this other tool, you certainly can put into a PHP MyAdmin SQL window, put it in here, and click Go to run the statements. So let's go over to the other interface. Here, we're using the same tables that I showed you in the PHP MyAdmin area. In fact, I have a link here called Your Database Grid, and this shows a list of the tables that we're using. Now, to get a sense of what we're going to do, I'm going to show you here the database diagram. So here you can see that there's tables structures already described in this diagram. There's an author table, book author, and so forth, and we've talked about before. But we want to create our own table with some kind of structure. When you create a table structure, you're not actually adding any data to it, not at that point. You first create a database object. In this case, the object is a table object. It is ready to receive data, but initially we just define what kind of data is going to go in there. So let's go ahead and take a look at a little example. First, I'm just going to show you the syntax of a create table statement. The syntax defines the rules that we use to specify information about a table. The keywords up here are create table. Those are required. Then you give the table a table name. Like you saw before, we used author or book. And you have parentheses that open and close the whole rest of the statement. And then we list column names. Columns are going to hold individual kinds of data. We could put a person's first name, a person's address, a zip code, a salary, anything like that is where a column would go. Usually tables have more than one column. So we have column 1, and then we give it a data type. We say what kind of data it can hold, and I'll talk about that more in a minute, and the size of that data. What's the maximum size that it can contain? If it's a number, for example, can it be a billion? Can it be just 10? Things like that. We can constrain the size. There are other things called constraints that we can put over here, and I'll describe a few of those as we proceed. So we list a column name with the data type, size, and the constraint, if any, and we put a comma. And then we do column 2, and the same thing, the comma. We do it all the way down till we're down to the end of here, and we have constraint, but we don't put a comma on the last one. So let me go ahead and get a real example here. I've copied in a create table statement.
I have create table and the word employee. I don't have an employee table right now, so I can go ahead and create one. If I tried to create one that already existed, I'd get an error, and then I would have to get rid of that old employee table, for example, and then create it again. But here are column names, employee ID. That's a common thing to have in a company. And I said that's numeric 9. That means it's a number that can be integers and it can be up to 9 digits long. Over here, I have a constraint on it. It's called a primary key. This is what we're going to use to keep track of individual rows in a database. And I'm going to talk more about that in a later lesson. I have the field last name, and we say we have a varchar. That stands for variable character length field. Someone's name could be just as simple as Lee, L-E-E, or it could be a very long name, and it would fit. As long as it's within 40 characters, it'll fit and be stored properly in the last name column. Now over here we have a different constraint called not null. That essentially makes the column required. We won't be allowed to add a row to the database without information in the last name field that says that this cannot be null. So think of it as a required field. We have the same thing here for first name, varchar 40, not null. And then I have a department code, what department the person's in. That's abbreviated, and I say that's a varchar 3, some code that represents their department. Now I have the word null here, which means nulls, or absent information, is allowed. Generally, I don't have to specify that null directly. I can just put the comma right there after the parentheses and not even say that explicitly. But it should work either way. Salary here, and here we have a different data type, numeric, where I give 8 digits of information, but the last 2 are considered to be a decimal, and nulls are okay. Hire date, and then I have a field called a date, which I don't have a size on, and in a later lesson I'll be describing these data types in more detail. And again, this one is not null. So now I'm going to go ahead and run this. I'm going to click on Submit SQL Statements. We get this information here, rows affected, create table, okay. Just some information that came from this interface that I'm using. The keywords we're looking for are statements were successful. How do we know that it really worked? I mean, it's nice to have these words here, statements were successful, but a couple ways you can check here with this link I provided. I can see now that I have an employee table, but a little simple way that also works, I'm going to clear this out. I can run a select statement against the table, put select and put from employee, and then go ahead and submit it. And while it doesn't have any data in it, at least shows that the column names are there that I created, and that gives me a sense that there is a structure in place where I will be able to add data to that. Table names should be descriptive and follow whatever naming standard might be imposed by an organization that you're working with. You don't need to avoid long table names, but you can always use something called table aliases as well to give a short version. The column name should be reasonably short and descriptive. Abbreviations are fine, like you saw I did department DEP underscore code. The column names, though, they cannot begin with a number. They have to begin with a letter. The last thing to cover here is how do you get rid of a table that's already there? Interestingly, the opposite of create is not destroy, it's actually drop. I have an employee table here, and if I want to get rid of it, I say drop table. I'm going to take that out, and then not from employee, but just employee. That is the table object that I'm going to get rid of. Drop table employee. So if I submit the SQL statement, it says they're successful, but again, if I want to be sure, I can try to do a select against it. Select star from employee and submit the statement. And it says there's an error. That database I'm working on is called pptest MySQL. Employee does not exist. That's the actual table name. That's, in this case, good. That's what we wanted. We verified that we did drop the table and that it no longer exists. In this lesson, I want to talk more about the column data types that are specified. There are 3 basic data types, 3 categories of data types that you need. You can have things that are character-based or text-based. You can have things that are numbers or numeric, and you can have dates or date time. So there's a special way that databases can track dates and time. Taking a quick look here at the table that we created earlier, employee table, if we look at the last name column specified, it's a varchar 40, which means the last name can hold up to 40 characters, but it doesn't have to use all 40 characters. The reason for varchar, which stands for variable character, is it lets the database not store a bunch of extra spaces if the names are short. My name, Perry, Perry, only takes up 5 digits. It doesn't store another 35 with blanks in them just because my name is only 5 characters long. It helps the database work more efficiently. And so that's the reason we do varchar. There is a char data type, which is not really used anymore. In fact, in PHP myadmin, if you specify char, it usually just goes ahead and changes it to varchar anyway. So you might as well just use this for most of the data types. There are other textual data types that you can read about, but pretty much varchar is the main thing you're going to need to use for anything that's a text or character field. Now you can see here where I have the department code with the abbreviation DEPT for department. I've limited it to 3 because it's not going to be bigger than 3. In fact, it'll probably always be 3. No sense using 40 here, even though it will shrink it down. This gives you at least a sense of the kind of data that you're going to be storing. 40 in this case is a maximum length. So if you had a name longer than 40, it would be truncated when you tried to store it into the database. Let's talk about numerics a little bit. We just use the keyword numeric. If we say numeric 9, we're saying, okay, it's up to 9 digits. Now, these are integers. They can be negative numbers as well. And if you need a decimal place, you have numeric, which it says, I'm going to reserve 8 digits for this number, but I want you to consider the last 2 to be decimals. So you say comma 2. And we use this type very often for money, as long as it fits within the 8 total digits. There are other numerics. There's integer, decimal, there's variations on a theme here. But since this is a quick class, you can pretty much get by with this. You can always look up other data types if you have some reason to have to shrink or to deal with numbers that are even smaller than a scientific application for some reason. But generally, numeric works just fine. Let's take a look at the date. When we say date, and we have here higher date, notice I used an underscore here. That's because you can't put spaces in the column names. They have to be connected somehow. If you have 2 words, you can connect them with an underscore, or you can use another system to indicate the 2 words, but you cannot use spaces. Date doesn't have a maximum size because the date format is controlled internally by the database itself. It's not something you can control. It's going to manage how it deals with dates and times. By doing that, we avoid the thing that caused the Y2K problem, where dates were all in kinds of different formats. So internally, they're only stored in one way. MySQL does offer functions that allow you to take a date that's not in the default format and put it into the default format. It'll convert it automatically. Likewise, you can extract the date out of the default format and display it in a different way. But inside the database itself, it's just one particular format that you have no control over. I'm going to type out here what a default data type looks like. I'm just going to say if we had data in there, MySQL uses this standard format. 212, that's 4-character year, a 2-character month, and then a 2-character day. There's ways to change that, but that's the MySQL default format. So you put hyphens in between there. Notice I put that between 2 single quotes. When I want to store data in a date field, as we'll see later, I'm going to treat it like it's a bit of text and put it inside quotes to get it into the date format, and it'll know what to do. So 4-character year, 2-character month, 2-character day is the default format. If we were to change this over here to be a date time field, where we carried both that, we would now skip a space and we'd have a 2-digit hour, 14 being military time, that's 2 p.m., and then a 2-digit minute, and then a 2-digit second. Hours, minutes, and seconds, and it would be stored in that format. MySQL does offer some other data types like timestamp and this sort of thing that can be used to track transactions and get the current date and time in there exactly as you're posting a transaction. So this is something you can look into just to do a Google search on MySQL data types, and you can see the list of some other useful data types that may be there. But these are the three broad categories, and you will be able to get away with using these three that I'm showing you here for almost everything you need to do.
This lesson is on what is a primary key and how do you specify one. A primary key in itself is a concept. It is either a column or combination of columns in a table whose values will be unique across the whole table. This ensures the uniqueness of a row. For example, let's go up here to the author table. There is an author ID and it's got a PK next to it indicating primary key. Whenever we insert rows into the author table, we make sure that we insert a unique number for the author ID. It'll never be repeated on any other row for the author table. This is the column or columns that we use to ensure that a row is unique. If we know the values of the primary key, then we know the value to get to a single row and no other row. It can be a combination of columns as well. So let me show you that. Notice here first, though, on the book table, we have ISBN. A book has an ISBN number, and that's guaranteed to be unique. So that is a primary key of the book table. Now, this table in the middle that we'll talk about more later in class, note that there are two columns here that have the PK with it. This is to indicate that these two columns together are the primary key of this book author table. It's a table we use to ensure that an author can write more than one book. We have author ID 1, book 1, author ID 1, book 2, and also that a book could be written by more than one author. You could have ISBN 1, author ID 1, ISBN 1, author ID 2. But the combination of those values are always unique. The FK over here is for foreign key, and that we'll discuss in a future lesson. So for right now, you need these two columns. So now that we have that, let's look at some statements that we would use to create a primary key. Go over to the MySQL interface, and I'm going to paste in a create statement that we've used before, but I want you to take a closer look at it. What you see here on this very first column, we have the words primary key, space in between primary and key, and the table here is the employee table. What the words primary key do is they ensure that the value stored for the employee ID in this numeric field will always be a unique number for the entire table. In other words, each row will have its own special number that won't be on any other row. But it does one other thing. It also enforces not null. Basically says this can never be empty. You must put a value in employee ID when you add a row to the table and you start adding data. So primary key is a constraint. It constrains this character to be unique, or this data type and this column to have a unique value, and it says that it must be not null. Not null by itself is a constraint, but all it basically says is you must enter data for this column in order to enter a row into the table. We enter this primary key information. It's usually done at table creation time. It's the most common. So let me copy in a different statement, and this is the book author table that had two columns for a primary key. Take that out, paste this in. Here's the thing to notice. I mentioned when I showed it to you in the diagram that both the author ID and the ISBN together are the primary key. Let's quickly go back to the diagram. So here's author ID and ISBN number. How do we specify that? Going back to the MySQL here. We can't just put primary key here and primary key here on these two columns. SQL won't understand what to do with that in this create table statement. So when we have a multi-column primary key, what we do is we go all the way to the bottom of this column list and we put the words primary key. I used all caps just for emphasis here. Primary key, there's a space there. And then in parentheses, I specify the columns that I want to make up the primary key. Author ID, comma, ISBN. So that's how you have to do it. Now, one thing to notice, usually you don't have a comma after the last column specified in the table list, but because you have this clause coming after it, you must use a comma here. So you just don't put a comma after the last thing. I'm going to take you now to the PHP MyAdmin window. If I click on the author table, it does a browse by default, but I'm going to click on this structure tab up here. And you can see there's a little primary key symbol up there with author ID. So this tells you right away that this is a key. If I wanted social security number to be also part of the key, I would select it here and either click that or click over here to make them all part of the primary key. Let's look at the book author table now. Again, we start in a browse mode. Let's go to the structure, and you can see there's two keys here to indicate that it's a two-keyed primary key. So I'll show you one other little feature here. See this little indexes thing with a plus tab? I click on that, and it shows us that author ID and ISBN are indexed. That basically helps ensure that this combination is unique. It says here unique, yes, and it says it's a primary. So we will learn more about indexing later. I just wanted to show you that it's easy to miss on this window. This lesson is on creating indexes. Indexes are objects that we can create on the database that will help speed up the queries or the selecting against the data of the database. An index on a database works a lot like the index in a book. So let me go over the concepts. Let's go over to a page here that's a clip of an index from a book. And you notice, like with a book, when we're looking for something, say we're looking up the concat function, we see that it appears on page 78, 79, 84, 85, etc. Character set clauses over here in 345. If we wanted to look for those terms and we didn't have an index or even a table of contents in this sense, we'd have to read through every page looking for these key words, and that would take a long time. So the same concept's true in a database. We need to give a way for the database to get to information quicker by creating an index. Now, we don't create an index in every column, but we do create them on some. This is the idea. Usually primary keys and foreign keys are indexed, but let's go back and look at the syntax for this. Create index syntax. The key words you need are the word create, just like when we had create table, and index. This word unique here in the square brackets, that square brackets indicate that it's optional. It's obviously not optional if you want the index to be unique across the whole table, kind of like a primary key, but it's optional to the statement running. Then you come up with an index name when you create one of these. You have to tell it what table, so you say on the table name, and you need to say what column name or names should be indexed together. Let's look for another candidate for indexing a particular column. I'll come back to the diagram. I noticed that the author has a social security number column as well as an author ID. Theoretically, we could have used the SSN as a primary key, but that's generally considered not a secure way to do it. But I do want to make sure it's unique. And just because these social security numbers are unique across the board when they're issued by the government, you might accidentally, or someone might accidentally try to enter the same one, make a typo. You're reading something off a list and you're entering data, and you want the database to prevent you from doing that. So I want to ensure the uniqueness of this SSN field. I'm going to take this out and paste in a statement. It says create unique index. I often put the table name and the column name. And then I just put IDX for index. That's not a standard. That's just something that I do. You may have another standard for naming at an organization where you're working, and so you follow that standard. But this is what I do. And I say it's on the author table, and the column I want to index is the social security number. If I run this, it says, okay, great, statements were successful. But how do I know what's going on? Let's go back to PHP MyAdmin for a second. Since I was working on the author table, let's go over here, look at the structure tab, and we'll look at the indexes again. And now you can see that there is an index name here, author SSN index. And unique, yes, it's unique. And it tells me the column. I can see that the index has been built. I can drop it from here because you can drop an index just the way you dropped a table. So these indexes can be created or dropped as need be. Now, one thing about indexes that are different from the indexes in a book is you don't decide when to use the index. You can define an index, you can create an index on a column in a table, but the database management system itself will decide when it's most advantageous to use the index. For example, if you happen to have indexed a field that could only have two values, like male, female, and the table you're dealing with has equal number of men and women, approximately, The database management system may decide, the index doesn't really buy me much here. So there's ways that can be optimized and find out whether an index is really needed. Often the indexes are created for the primary foreign keys and things that you can put in a where clause and a select statement, as I briefly showed you in an earlier lesson, and we'll go into more detail later. Things you're going to search on are things that are helpful because you want to get through the data. In this class, we're using just a small database, so you can look at all the data and not really have a problem. But in the real world, data could be thousands or tens of thousands or millions of rows, so it's not practical to go through them manually and try to spot this. So these tools are available to you. Let's go back to the MySQL window, and we're going to bring in another example. Take that out, paste a new one in. Here I'm going to create a non-unique index. I did not put the word there because I want to put a non-unique index on two columns together. It's very common to look for a last name and first name together in one where clause, one search for some rows. And so I still can speed things up just like I would for looking at a name list on the internet, or if you're older, a phone book where you'd look through all the last names first, and then within the last name groupings, you'd look for the first name, and it would be in order. And that's a quick way to get to the information you need. You can do this and create that index as well. So when you want to get rid of one, as I mentioned, you can do a drop. So the basic idea is simply drop index instead of drop table. You do give the object name, the index name, but you do have to say on author. You have to give the table name as well. So I run that, says it was successful. We'll go back to phpMyAdmin. Let me refresh the table here. Back to the structure, and we'll look at the indexes again. Now you can see that the index that was there is no longer there, so the drop worked. This lesson is on modifying the table structure after you've already created it. Now, if a table's empty, there's no rows in it, of course you can drop a table and just make another create statement the way you want it to be. But you may want to modify some things after the table's been created and data's already been added to the table. So for that, we have something called the alter statement. And I have it up here. It's called alter table. This is the syntax, alter table, and the table name that you wish to change. Now look at the second line of the syntax. There's these up and down bars here called pipes. And in syntax land, that means or. So we can add something, or we can modify it, or we can drop a column, or we can change the definition of a column. Those are the four basic kinds of things we can do with an alter statement. Let me show you an example. Say I want to change the maximum value for the last name column in the employee table. So I want to change it from varchar 40, and now I want to make it varchar 80. So let's go over to the phpMyAdmin window and take a look at the structure of the employee table. Last name is currently varchar 40. Back to the MySQL interface, and I'm going to go ahead and run this statement. And it said that it did it. It says, okay, modified. Statements were successful. Let's go back and look at phpMyAdmin to see the change. Let me refresh the table, go get the structure, and you can see now it says varchar 80. So I've increased the maximum last name value that I can have in that column. It can be greater than 40 characters at this point. Let's look at another example. Say I decide that I want to add a phone number column onto the end of this employee table. Let's go back and look at that. So I'll take this one out. Let me just clear that, and I'll put this in. Alter table employee, add phone. That's the column name, and I want it to be defined as numeric 10. So I'll run this statement. It says it's okay. Go back to the phpMyAdmin, refresh the table, and now we can see there's a phone column on there. Notice it put it in there as decimal 10, 0. So this is the MySQL interface behind just saying numeric 10 and decimal 10, 0 are the same thing. So it just made a little conversion for us. It's not a big deal. We can just accept that. Now let's say we thought better of it. I don't want people calling my employees, so let's drop the phone column. And we'll go over to the MySQL window again and clear this. Paste it. So there it is. Alter table employee, drop column phone. I'll run that. It says I have an error.
In this case, you don't use parentheses around the column. It's just drop column and you give the column name. So let's try that again. And it says it's okay. Go back to phpMyAdmin and refresh the table. Clicking on it, look at the structure, and the phone column is gone. The alter table statement will allow you to make changes after creation. This lesson is on adding rows of data to a table. We do that with the insert into statement. Here's the insert syntax. So this is an insert, and then you use the keyword into. After that, you tell it the table name. Now you can only insert into one table at a time. Now here's how to read the syntax. Remember, the square brackets indicate that this is optional. This is where you list what column names are going to be filled in with data. The only time it's optional, however, is if you list all of the values below here that correspond with all of the columns in the table, and you do it in the same order as the create statement. I think it makes more sense to almost always specify the columns, then it's crystal clear what's going on. So I'm going to show you an example of this. Paste in an insert statement. Let's look at this. We insert into the publisher table. The pub ID, this column is the name of the column. We're going to give it a value of 5. The name is going to be Jarden Incorporated. The address is just the street address, 55th Avenue. City is Camden. State is New Jersey. This has to line up perfectly. If you have 5 columns specified here, you have to have 5 columns full of values specified. If you had something missing, you could put the word null in there if nulls were allowed. Let's look at what we have in there currently before we run this. We'll go over to the publisher table and I'll browse it. I've got 4 statements in there: Binder and Smith, All Techo Books, Sunshine Publishers, and Far Out Books. Let's go here and run this insert statement. It says, okay, statements were successful. Let's go back and see what's refreshed the table. Click on this, and you can see that 5 Jarden Incorporated has been added successfully. Now let's look at the structure of the table. The only required column is the pub ID. It says nulls no. That means you have to fill it in. None of these other columns were set up with not null on them. Kind of makes sense to require a name, I think, but it wasn't done when this table was created. Theoretically, I could add a row by just putting in the pub ID, but let's go ahead and put in a pub ID and name. Go back to the MySQL interface, clear it out, and I'm going to paste in this statement. Here we insert into publisher, and in the parentheses, I have pub ID and name. That's fine, and I gave it a 7 and health text. So I'll go ahead and run this. It says it's okay. We'll go back to the phpMyAdmin, and I'll refresh the table. And you can see I have health text 7, but these other values are null because I said nulls were allowed when the table was created. That's it in a nutshell. There are ways to insert more than one row into a table at a time using a subselect, but when we get into subqueries later in the course, that'll become more apparent how to do that. This lesson is on changing data that is already in a table. Now to do that, we use the update statement. Let's look at the syntax over here. Update, and then we give the table name that we want to update, one table at a time. Now here's a new clause. It's called the set clause. And you set the column name in the table to an expression. The simplest expression is just some value, 3, Steve, something like that. You can have more complicated expressions than that, but usually it's just a value. And then you have a comma if you want to change a few more columns in the same update statement. So column name 2 equals expression 2. And then the ... to just say I could continue doing this for all the columns in the table if I wanted to. Optionally, square brackets is optionally, I can have a where clause. And these search conditions are matching conditions that I use to minimize how many rows in the table are updated. Dangerously, SQL is set up so that if you specify less, if you leave off the search conditions, you will change every row in the table. And if that table has 1,000,000 rows in it, you will have changed 1,000,000 rows. So it's good to be careful. Let's go ahead and look at this by example. So let's clear that out, bring in a statement.
Doing this, if I said update book, set price, there's a price column to be $17.99. Without a where clause, I'm going to change all the rows of data in the table. Let's do it this way. I'm going to do a select statement, and I'll just say star or asterisk to tell me to bring back all the columns. So I'm going to say select all the columns before the update statement, then do the update statement, and then select all the columns after the update statement. And I'll go ahead and run this. So you can see at first we have lovely prices, different prices per book. So there's a few repeats, but basically it's a different price and some things are null. Then we run here the update statement. And now we see the select statement and the price of every book, including the one that was null, is now $17.99. Probably not what we wanted to do. I'm going to go back and reset the data. So I'm back in this window and I've copied in another update statement. Also, I've reset the data so the prices are as they were. So now I'm saying update the book table, set the price to be $19.99, but only do that where the price is $29.99 now. So I'm going to lower the price on those books that are listed at $29.99. Let's take a quick look here what the current data looks at. We've got 1, 2, 3, 4, 5 books that have $29.99. Are there any with $19.99 in here already? Doesn't appear to be. This is the advantage of having such a small set of data. We can just look it over and make sure it's the way we expect it to be. Let's run this statement. It says rows affected 5. That's good. We counted 5. And it set the price to $19.99 where it was $29.99. So let's run a select statement and see if it did it. You can see, looking at the data here, 1999, 1999, the two there, and then the one all the way down here, how to choose a computer. So the changes were made to the table, as we would have expected. So let's narrow this down a little bit more. Let's bring in another statement. Often it's a good idea to go in the where clause against the primary key, but I happen to know that the titles are unique. So I'm going to look for the title called Analyzing the Obsessive, and I'm going to change the book price to $17.99. It's $19.99 now, so let's go back up. And I shall copy that statement in, set price $17.99, title Analyzing the Obsessive. Also, one thing to note here, whenever you're dealing with numbers that are strictly numbers, you don't put these expressions in quotes. But things that are textually based, you wrap them in double or single quotes in MySQL. Either one will work, but it has to be the same at the beginning and the end. So let's run that. It says it was successful and it just did one row, which is what we would have expected. I'll copy the book table select statement here, look at it again. Analyzing the obsessive, it's been changed to $17.99. I'm going to show you one more thing where we do things in a little bit more complicated way with expressions. Let's clear this out, bring this in. Here, I'm going to double the price of books. I'm going to say update the book table, set the price to be the price times 2. Now, whenever you see an equal sign in anything to do with programming, you do the stuff that's on the right side of the equal sign first. So the current price, whatever it is, I want you to multiply it by 2, and then on the left side of the equal sign, override whatever price is now with this new value. So that's how this works out. Now here with the advance, I'm going to raise the advance by $1,000. So advance plus 1,000. But I'm only going to do this where the year-to-date sales on the book is greater than 10,000. So let's go ahead and run that. It says it affected 3 rows. Again, select from the book table and try to get a feel for this. Run it. This one's greater than 10,000. So that went up higher. And this one's greater than 10,000. We've doubled that price, as is this one. So there are just 3 rows that were affected, and we've doubled the price. And we've added $1,000 to their advance. This lesson is on removing data from a table. Just like with the insert into table statement, we inserted rows of data at a time. The update statement changed individual columns on rows in the table. But with the delete statement, it's like the insert. We have to remove rows of data. You don't delete just columns, you delete rows. So here's the basic syntax. Delete and from is what you have to say. Then you give the table name. You could only delete from one table at a time in one statement. And once again, you see the search conditions, where search conditions, and it's in square brackets. So it is optional to specify search conditions. However, if you don't specify them, you delete all of the rows in the table. Kind of dangerous. So let me show you what I do usually. Instead of doing this, and then I accidentally hit the enter key, and oh my God, I got rid of all the data. What I do instead is when I'm coding these things, I bring in the where clause first. The where clause says I only want to delete rows where the price is $2.99. So let's go back, and now I put in delete from book. Another technique is sometimes to do a select from the book where the price is $2.99, and we'll be going over the select table in more detail. So let's go ahead, let's see what we've got here. Do we have any books that are $2.99? There's the book table. We have prices here. We have none that are $2.99. I'll pick Instilling Courage, that's $17, so we can see something happen here. So let's do that. Let's say $17. Even though I'm saying dollars, you never do this. You don't put money formatting characters in the data. The decimal place is pretty much the only thing you can have. So let's go ahead and run this. And it says it affected one row, which is good. We'll go back and look at the phpMyAdmin. I'll click it to refresh. And the book that was $17 is no longer there. It is gone. So we got rid of that information. Let's look at one more thing here. I'm going to do something slightly more complicated in the where clause. Go back to the practice area, clear it out, and paste. So I'm going to go to the author table, and I want to delete all the authors where the city equals Oakland and the state equals California. If we had a very big author table from around the country, there are other states that have an Oakland. It isn't only Oakland, California. So if I want to make sure I only delete the ones from Oakland, California, I do it this way with an and in the middle of it. Let's go look at our data. Start out, go to authors. We can see there's an author from Oakland. 1, 2, 3, 4, 5 authors from Oakland. We currently have 23 rows total. So we should have less after we run this delete statement. Let's go over here and submit the statement. Delete where Oakland and California. Come back to phpMyAdmin, click the table to refresh it. We have 18 total records. So we got rid of the 5, and we don't see anybody there from Oakland, California anymore. So that's how the delete statement works. This lesson is on retrieving data from a table. In its most simplest case, as you've seen before, we have select, and I have an asterisk or a star from the book table. This says, show me everything you got, all the columns in the book table. So let's go ahead and run this. All SQL select statements come back as what we call a regular grid. In this case, this is the way the table looks. This is all the data and all the columns and all the rows that are in the table. And anytime we select information from the table that's less than this, and we restrict it in some way, it'll still be returned as a regular grid. There'll be 2 columns over and number of rows down. There'll never be any like blanks or irregular patterns. These regular grids, of course, are known as relations, mathematical relations, and that's where we get the term relational database. We have a very small table here, so it was no big deal to just get everything. But in the real world, when we deal with hundreds of thousands of rows, we don't want to select all the rows, and nor do we want all the columns. The ISBN number here probably isn't useful in a regular way to have that print out all the time. So let's just deal with a couple of columns here. I'm going to look at the title of the book and the price. Let me clear this and bring in a different statement. So I'm going to select explicitly the title column and the price column and no other columns. And that's still from the book table. And we're going to get all the rows. Click this button. And now we see just the title and the price of the book. And we get it for all 16 rows of data. Notice in this case, I don't have a price for this book, Psychology of Social Networking, and it's considered null. Any missing information in a database is considered null. It's not really blank or 0, but that's the way I display it on this interface. But again, all the rows of data. So we'll learn in another lesson on how to restrict that. I want to stick with restricting the information just a little bit here, the columns. So first I'll select everything from publisher. Let's put that in and click the statement. So we see I've got 3 publishers in no particular order, and they're all written out. And if I want to restrict that a little bit, I don't want to see the pub ID because what does that number mean to anybody? I just want to see the name and the city and the state. So I'll bring in another select statement here, and you see select, name, city, state. You put commas between these columns, but you don't have a comma after the last one. In fact, you want to make sure there's a space there as well because you don't want it to run into the from clause. The from gives us the table name. So let's run this. And now we see publisher name, city, and state, and that's it. That's the basics of how you retrieve data from a table. This lesson is on restricting the rows that are returned from a select statement. Let's go back to what we looked at before, selecting everything from the book table. First, I'll run that, and we see we have these 16 rows of data. So now, if I want to restrict this, I can use something called the where clause. It's in the select statement. It comes after the from, where, and then after that, I specify some kind of criteria that has to be passed by the row to say, yeah, this comes back in the result list. I want to see only books where the price is greater than 20. So if I look at here, that one's greater than 20, greater than 20, greater than 20. Okay, a lot of these are greater than 20. Ah, here's one, $12.99, stressed for success. Here's one for 17. These are not supposed to come back. The null value, which means missing, data's not been put in there yet for this book, those don't pass the test. By definition, nulls don't pass any test. So you can see I'd reduce the rows by at least 4 with a null. So let's just try it. I'll run it now. It came back again. I have 12 rows instead of 16. If I raise it up above, make it greater than 30 now. I only want to see books greater than 30. Now I'm just down to books that have 40, 42, and so forth. I've restricted it with a where clause. That's what the where clause is about. You give the positive criteria that each row is validated against to decide whether it should be returned to the result set or not. Just as we saw in a previous lesson where I restricted the number of columns, I can do that at the same time. Say I only want to see title and price. I take that out and I put in title and price, but only for books where the price is greater than 30. Run it, and there we are. Titles, price. And again, I can change this as much as I want. I can go back to 20, and we'll see many more rows of books of $20 or more in price. I don't have to use mathematical comparisons. I can compare on some kind of text. So let's look at the publisher table. Clear the box, and I'll bring in the publisher statement, and we'll see the whole table because it's pretty small. Say I only wanted to see publishers that were based in Cupertino. I can take a where clause on here, and I can put that in. Notice I took away that semicolon. Semicolon is a terminating character that says the statement's done. So I say, give me everything about the publisher if the city's Cupertino. I can see here that I only have one, but we could have had more. Maybe Binder and Smith was also in Cupertino, and we would get 2 rows back. Here we just get the 1 row. And again, I may not want to see everything about the table. I may only want to see the publisher's name who's in Cupertino. So I get rid of the star or the asterisk and I put in name. Run it. There we are, all Techo books. So that answers the question that I was asking. That's it in a nutshell. The where clause can get a lot more complicated, and we'll go over how to do that in ensuing lessons. But this is the gist. You specify conditions in the where clause to decide what gets returned from the select statement. This lesson is on using mathematical and text expressions in a select statement. Let's go back and look at a simple case here where we just select the title and price from book. We'll just start with that. We got title, price, and we got it for all the rows in the table because there's no where clause on here. But let's say we not only wanted to see the price, but we wanted to see what would the price be if I raised the price by 5%. So I can put an expression here that's more complicated than just a column name. I say price times, the asterisk represents a times in SQL when used this way, 0.05, and that'll raise the price. I submit this, And we can see what the price would be, 42, 31, if it was raised a little bit. And we can get a feel on whether we think we can get away with that, raising our book to that price. Again, it has no effect on a null value. Let me bring in here a little bit of documentation about what you can do and not do with these statements. Clear that. I'm going to copy that in. So this is the standard mathematical operators. Addition is just like always, it's a plus sign. Subtraction is a hyphen. Multiplication, unfortunately, it's not a little x. It has to be an asterisk for it to be recognized. Division, we don't have a symbol where we have a hyphen with dots above and below it. We have to use a forward slash for division. Now, there are more operators, but these will do to get us going. There are ways to do much more complicated expressions if need be. Notice that you can use parentheses the same way you do in math. If you want to force this addition to happen before the multiplication, you want to make it clear that's happening, so you put the parentheses around it and you get 7 plus 5 times 8. And so we can do this with column names. It doesn't have to be literal numbers. We can use column names that will actually process it, just like when we said price times 2. Price was a column name. So let's move on and look at another example. Let me clear this out. We'll paste this. Now we're saying title, price times year-to-date sales. What does that mean? That means year-to-date sales are how many books we've sold so far times the price. So that's how much money or revenue we've gotten in. Click that, and we can see this book has brought in this much money. We sold this many books times what the book cost, so that's the amount of revenue that was brought in per book. And again, nulls don't mean anything. Now, you can't get nice formatting here, not easily. It's not something that you do usually with SQL. It's usually done when you want pretty formatting. You either use a computer program of some kind where you issue SQL and then format it within the program, or there are SQL report writing tools out there like Crystal Reports and ReportSmith, and these tools are what you would use to format the data better. But this is what it looks like in SQL, just the way the data comes out. I'm going to show you a nice little thing here. Instead of just seeing price and times year-to-date sales up here as the default, we can override that to have it be a little bit more meaningful. So what I do is I skip a space after the expression, and I'm going to put in the word revenue, and I put it in double quotes. Now let's run this again, and notice that the heading now says revenue. So that really represents what that number is. It didn't have to re-show me the formula up here. Now we are working interactively here. We're typing statements in, clicking a button, seeing results. Much of SQL in the real world is issued from a computer program ultimately, but you need to know how to work with it interactively to test it out, even if you're a programmer. The last thing I'm going to do here is show you a simple text expression instead of a math expression. Let me clear this out, and I'll paste this in. Here, I have in single quotes, you could do it with double quotes in MySQL as well, but single quotes, I just have a word, publisher colon space, close quote, the column name for the name of the publisher, then another open quote is based in close quote, and I've got spaces around it. And I've got city and state. So this will make it look a little more sentence-like. Let me run this. And you can see, even though it's in separate columns, it reads a little bit more like a sentence. Publisher Bender and Smith is based in New York, New York. Publisher Techo Books is based in Cupertino, California. So you can do this, which is useful. It just puts this text thing on every row that's returned from the results set. Now the publisher only has 3 rows in it, so there's not much more we're going to do there to restrict it in any way. But this gives you the idea, so you can do this where it makes sense. There is a way that I'll show you later that you can put data together so it all appears in one column as a sentence, but that's for a later lesson. This lesson is on sorting the results that come back from your select statements. Looking at a statement here, title and price from the book table, where price is greater than 20, we'll go ahead and run that. You can see it's not brought back in any particular order. S, O, A, W, it's not alphabetical or the prices aren't in order. There's no way you can expect that a table will always be in order by default in some way. You always need to force the issue. The way to do that is with something called the order by clause. Order by. Now, what do we order by? We're going to order by a column, sometimes more than one column. But let's just take this in the simple case. We're going to order by the title column. So when I do it this way, I'm saying I want the results sorted in alphabetical order. It's ascending is basically is the default. It'll go from A to Z. So I'll run that again. And you can see now, analyzing D, G, things are in alphabetical order on the title. I wish it were called sort by, but it's not. You have to use the word order, space, by, and then give at least one column. Now, if you wanted that sort to be in reverse order, instead of accepting the default of ascending, like A, B, C, D, you can put a space and then you put in D, E, S, C. That stands for descending. You don't spell out descending, you spell it just like I'm doing. It doesn't have to be capitalized, but it does have to be just that, this abbreviation for descending. I'll run this, and you can see now W, U, T, down to A. So it reversed the order. We can do a kind of sort where we sort on more than one column, and I'm going to show you that. Let's go up here and I'll clear this and paste this in. Now I'm going to go on the book table. I'm going to say type. I'm not saying title now. I'm saying type price. So type's like a computer book, a cooking book, what have you. Order by type price. So let's see what happens. I get this null group up here. I could get rid of that. We'll be going over later how to eliminate nulls from your results. But for right now, we'll just ignore it. It did by type in sorted order. Put the business, books, type, and a couple computers, couple cooking. We don't see the titles here, but we see the categories or the type. Now, within each grouping, like here you've got 4 books for business, they're in numerical order from lowest to highest because I said to put the price as the secondary sort. I was saying put this in order within each grouping. If I showed you that without price in there, here we'd get the number 2195 comes after 29 and after 12. It's not in order. So I added that secondary sort of putting price in there so it would be in order. That was the key there. So you can force the issue to have something, a secondary sort within the groupings found in the first sort. If you're ever looking at a name list, you look at someone's last name, Perry, 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 and then you get there and say there's Abraham Perry, Charlie Perry, Steve Perry. And so you see the first name sorted within the Perry group. And so that would work. One last thing I want to show you here is that you can use an abbreviation. This is when you're working interactively like we're doing now. If you don't want to type out the column names again, you can put the positions that they appear in the select list. Type appears first, price appears second. So if I run this, I'm going to get the same results. Now I can put descending on just one of them. I don't have to put descending on both. So I put descending on the second list, that's price, and run it. And now you'll see in the business grouping, it starts with the highest price down to the lowest price within that grouping. And then we bounce back up to 42 because we have a new grouping here, computers. You can put the position in there. Remember though, if you accidentally stick another column in while you're doing that, all of a sudden it's a different order. It's going to be sorted on title and on type that way. So you've got the alphabetical order and then type would come next if you had titles that were the same, which we won't here, so we won't really see a result from that. Just be aware if you're using the number shortcut interactively that will get altered if you mess things up and change the column list as you're working. Generally, if you work in a computer program and you do SQL there, you want to spell out the column names. It's worth the extra work just to be super clear on what's going on. This lesson is on using comparison operators in the where clause. Now we've done some of this already where we used equality. We said where price equals 20, or we said where price is greater than 20. But there's some other operators here that we can use. We can use greater than or equal, less than or equal. You can do not equals this way, but the more common way to do not equal is with an exclamation point equal sign. So we look for inequality when we're doing something like that. Let's go ahead and look at an example here. Clear that and paste this in. So I want the last name and first name and state from the author table, but I don't want to see anybody from California. Say where state is not equal to California. So it eliminates all the rows where they are equal to California. And then I order by last name and first name. Let's run that. And you can see Robert Blue, Jose Castillo. So it goes down and it does all this information. It gives you the information that you asked for. You don't have anybody there from California. So that's good. Another thing I'd like to show you is how you can look for a date. So I'm going to put this in here. We're going to just do it by quality right now, but when you put a date value in there, you put it between single quotes and it behaves like you would for string data, just like when we were looking for analyzing the obsessive against the book table. Now it knows it's a date because this column is defined as a date column. And this date is the default format where MySQL stores a date. It stores it as a 4-digit year, a hyphen, 2-digit month, hyphen, and a 2-digit day. So it's going to look for that match exactly. And then I ordered by title. So let's go ahead and run this. And so you see I've gotten 2 that are at that publication date. This is a default. We're going to go in later on how to use functions to deal with dates that aren't in the default format. But for right now, this is how you would do it using the default format that MySQL uses. Do another example here, and we'll do a greater than equal. So title price greater than equal to 17. So let's run that. Look at the results. And you'll see we have a book, Still Encouraged, that's exactly $17. And that got returned because we said greater than or equal to. If we took out the equal and just used greater than, that would disappear. It no longer passes the test. We don't have the Courage book. You can use these comparison operators just like you do in mathematical equations. It's pretty straightforward. You'll learn some other ways to group information with parentheses and not operators that will help you control the where clause criteria even more. This lesson is on logical operators. Logical operators are basically using an and, an or a not condition. I have placed here the use of and as a logical operator. This connects two sides of a comparison and examines them for truth. And if they're true, it brings back a row. Let me go in a little bit more what I mean by that. Here we select last name, first name, city, and state. I'll go ahead and take this out and we'll run the statement alone. So we see we get everybody. We get all these people. But if I do this, I say submit SQL statements, I get only Cindy Hunter, which is what I asked for. Last name Hunter, first name Cindy. Both of those have to be true. The last name must be Hunter and the first name must be Cindy for a row to be considered to have passed the where clause criteria and display in the results set. I'm not likely to have more than one Cindy Hunter, especially in a small database. But if you have a database with 50,000 employees in it, you might very likely have multiple Cindy Hunters, so you would get multiple rows. That's the way you evaluate truth with an and. Both sides of the and have to be true individually. The row has to be tested for does the last name equal Hunter and does the first name equal Cindy before the whole thing is considered true. So let's look at this a different way. And I'm going to bring in a SQL statement with an or. So in this case, I'm going against the author table and I say last name, first name, city, state from author, where the state is California or the state is Utah. What this says is only one of these has to be true, or both could be true. Now, in reality, someone is not going to live in two states, but from the logical operator standpoint, if one side of the conditions, one side of the or is true, then the whole thing is considered true. So as we go through and look at the row of authors, let's do this again. I'll get the whole table back. I look at this and say, oh, are you California, Utah? Cool. Yes. Bring it in. Are you California? Yes. Are you California or Utah? No, you're Illinois. So we don't bring that one back. So let's bring this back again. So let's run this. And you can see we have people from Utah and authors from California. And that's all we see. And that's all we should see based on this statement. You have to be careful when translating English into SQL. Someone might say to you, oh, I want to see all the authors who are in California and in Utah. And they mean I want to see both California and Utah. But the way you get that to happen in SQL is to use the or logical operator. So if they're California, they'll appear, or if they're Utah, they'll appear. So essentially, you get them both. Let's take a look at the not criteria now. Clear everything here. Put that in. So I have a statement here again against the author. I'm saying, give me all the last name, first name, city, states from the author table. We're not, and then I've got these conditions in parentheses. So the way it works is very much like math. I do what's in the parentheses first. I look proactively. Are you in California? Yes, and I mark that row. Or are you in Utah? Yes, I mark that row. So first, behind the scenes, it determines all the rows that have California and Utah. But because it has a not in front of this clause, it then throws all those rows away and gives me every row that was left over. So let's run this and maybe it'll make more sense. So here I see Illinois, Maryland, Tennessee. I see all the authors who did not live in California and did not live in Utah. So that's the way a not works. You can do a simpler not by just doing something like this and just say, we're not California, and I can run that, and I've got everything. Now I've got the 2 Utah people back, but I had a lot of authors from California, so we eliminated those by using the not. So you may be looking at this and thinking, well, couldn't I have done this another way? Yes, in a simple case like this, I could have just taken that not out and put the exclamation point there and used the not equals operator, and I would get the same thing. So that works too. Let's go on. I want to give you a warning about mixing nots and ors together. I've cleared this out and I'm going to copy in this. Warning, do not mix nots and ors in the following manner. Same information from the author table. I don't want to say we're not state equal California or not state equal Utah. Because what happens here is it's always true. A person can't live in California and Utah. They can live in one or the other or live in some other state entirely. The way this is evaluated is it looks at this clause and says, if I live in Utah, it says, do you not live in California? Yes, true. I bring it back. If I lived in California, it says, do you not live in the state of Utah? That's true. I live in California. Only one side of the or has to be correct, so I'd get a return. Otherwise, if I lived in Illinois, I'd pass this test. Do I not live in California? True. So every row passes this test, and that's not what you probably want. Let's run it. Oops, we have a little error. Basically, this is an error that I put out to just warn not to mix ors in this manner. So I came over here to PHP MySQL so we can see this statement run. So it's a little hard to read. It's a little small in this interface. That's why I use the other interface to help you see the statement. But it's the same statement I had before, not equals California or not equal Utah. So I'm going to run it by clicking Go. And you can see that we bring back all the authors once again. We have 23 rows returned up here. We don't want that. That's not what you're really trying to do. This lesson is on dealing with null values in the database. As I've shown before, if you don't have any information to put in a particular column on a particular row, no information is filled in, and that is called a null. It's not the same thing as a blank or a zero. It's truly missing information. Let's look at the book table here. I'm going to bring in a select and get everything from the book table. And we'll scroll down here and you'll see we have one row for the book, The Psychology of Social Networking, where we have nulls for the type and price, advanced, etc. Several columns with a null value. If we want to deal with that, and we don't know how many rows have null values, but we want to find that out, we deal with nulls by using special constructs called is null and is not null. These are essentially operators. Let's bring in a very simple statement here. Go to the top, we'll take that out, and I'll paste this in. I say, give me the titles from the book where the advance is null. So I run this, and we just have one book. If I want to get a warm fuzzy, I can go ahead and display the advance as well in the statement so we can see that the null is there. So this gets the null. If we wanted to see all the books where the advance was not null, we just simply do that. We say is not null. And then I go ahead and run that. And we're getting all of the other books that have some kind of value, including zero. You see, Treats and More Treats got a 0 advance. They published the book, but they didn't advance any money. That's not the same thing as a null. That 0 was intentional. It's not missing at all. So it's pretty much as simple as that. Is null or is not null. Now I'm going to show you something that you don't want to do that won't work for you as you intended. Let's take a look at this. Clear that out and bring that back. Never do this. Select title advance from book where advance equals null.
There's no such thing. Null technically doesn't equal anything. It's just missing. So this will never get you what you want. Nor can you put it in single or double quotes like this, where advanced equal null like that. That also will never work. So remember that. It's an easy mistake to make when you're first starting out with SQL to try to equal null, but you have to use is null or is not null. These conditions, of course, can be combined with any other conditions with ors and ands and so forth. This lesson is on the concept of foreign keys. You already know that a primary key is a column or combination of columns that's used to ensure the uniqueness of a row in a table. A foreign key is a column or combination of columns in one table that refers back to the primary key of another table. This relationship between a primary key and a foreign key is what we're going to use to connect data from two tables back together. So let's take a look at the database diagram for the book publishing database that we're using. Let's use a very simple relationship. We'll come all the way down here to the publisher table, and we see that it has a primary key of pub ID, just some code that represents a unique publisher in our publishing house database. And so we've got the information, the name, address, city, state. Now we have a book table. Its primary key is ISBN. And then we have a bunch of information about the book, the title and the type. And look here, we have pub ID here as well. Right next to that is an FK representing foreign key. There's a value in here that is the same value as the unique code in the publisher table for the publisher that publishes that book. So we have to find a way with data to tie the publisher to the book that's being published by a publisher. And we do that with this foreign key, primary key relationship. You'll notice here that there's a straight line, and then there's something that's affectionately known as a crow's foot. There's a concept when we talk about relationships between tables. One of the most important relationships is what's called a one-to-many relationship. One publisher can publish many books, and many here basically means one or more, in some cases zero, one or more. That represents the side of the relationship that can be zero, one or more things, in this case books. Over here where we don't have the crow's foot, that represents just one of these to many or more than one of these. That's an important way to join tables together. While the goal when putting together a relational database is to reduce redundancy of data, some redundancy of data can't be prevented. In particular, we need the publisher ID to be repeated multiple times, even to identify the publisher that published this book. So this is what we're going to use in data, and we'll join these two together and pull this information so we can put out a report or a result set that has information about the publisher and about the book in just one select statement. That's a concept called joining, and we'll be covering that in a future lesson. We'll just briefly look at this in data. Clear that. We'll do two selects. I'll select from publisher, semicolon, and then select from book. And just to be consistent, I'll make this capital, although it's not strictly required. So I run these statements, and we see that we have publisher 1, 2, and 3. I didn't put an order by on here, so they're not in any particular order. And if I look over here in the book table, I can see I have pub ID column, and there's 3s and 1s and 2s and so forth. So I can pull these data together by connecting the pub ID to the pub ID of the publisher table through the joining operation. So that's what's really important about a foreign key. It relates back to the primary key of another table so we can get data back together. This lesson is on joining tables together using the using clause. Just talk about the concept of joining again briefly. We have a publisher table and books that are published by some publisher. And so we have a column in common. We have this foreign key, which contains the value of a primary key of one of the publishers. So that will tie in all the information. Simply by knowing the pub ID, I can get this information and then I'll know the name, address, city, state. I'll get all that as well through this thing called joining. So let's go here and look at a statement. There's a keyword called join. Thus far, we've only seen one table in the from clause, but here we're going to have to list two or more, but in this case, just the publisher table, join, book. And now here's the thing called the using clause. When we specify using, we're saying that there's a column name that's the same name between two tables and similar values. In this case, the pub ID standing for publisher ID. When we use the publisher ID, we're basically saying, look to where the value of the publisher ID on this table is equal to the value of the publisher ID on that table. So it joins them through equality. So it's a bit of a shortcut. There's another clause that I'm going to show you about later that allows you to do more complicated relationships. But in most cases, we have similar or exact column names looking for equal values. So the using clause works just fine. So let's go ahead and run this. We see all Techo books, how to choose a computer, all Techo books, 1 hour negotiations. And then we see the other publisher, Binder and Smith, and the last one, Sunshine Publishers. And it's all ordered very nicely because I used order 1, 2. Of course, I could have specified name and title, but I used the shortcut. Within each grouping of books, it's ordered HOSU. It's in alphabetical order by book. So it's a very nicely sorted result set. Now, it may be confusing to you at first to say, well, wait a minute, why are you repeating this information all the time? Couldn't I just put all Techo books up here and just not repeat it here? That would be nice in some report that you wrote in a computer application where you could strictly control the formatting. But with SQL and select statements, all results of select statements come back as a regular grid. Mathematical term for that is a relation. So we have the same number of columns, same number of rows. It's all regular. There's no unsightly spaces. I can't take that out and put just blanks here to make it read a little better. More sophisticated formatting is done with another computer programming language that issues SQL. Basic SQL itself sends the data back on a per row basis. So when you join information on a tables, it's common to have data repeated in the results the way you see here. So I want you to notice one other thing. In the select list, I put the column name, in this case was just name, and the column name title. So how did it know what table to get the information from? In this case, the column name represents the publisher name, and it only appears on one of these tables. Going back and looking at the diagram, you can see that there is no name field on the book table. We have a title, but not the word name. The column name is only on the publisher table. So SQL knows what to do. It says, cool, name, I want to get that in title. It's only in one place. The pub ID is in two places, but because of using this shortcut, the using clause shortcut, it knows, that means I've got a pub ID in both places. I don't have to do anything special to say, get the pub ID from the publisher and then get the pub ID from the book. It knows what to do. Now, there are cases where we're going to have to be clear about where a column comes from in one particular table when column names are repeated. So let's look at another example here. I'm going to take that out and I'll paste this in. We're going to join by pub ID. Again, same thing as before, but we can specify where criteria, as complicated as we need be. So in this case, I run the statement and it's only looking for joins. It's only going to consider to join information where the price on the row is greater than 20. What happens is the select statement first eliminates all the rows where the price is not greater than 20 and it only returns greater than 20. Now it does that behind the scenes. And then behind the scenes, it figures out with what I have left, let's join the information between the publisher and the book table on the publisher ID. So you can see here, I have 5 from all Techo books and only 4 from Binder and Smith and only 3 from Sunshine Publishers. So Sunshine Publishers has some books that are not priced above $20. So they were eliminated from consideration when we tried to do this joining together of these two tables. I'm referring to this as a join. Sometimes it's referred to as an inner join, but join is what I'm going to use. There's another kind of join called an outer join that we'll cover in a later lesson. This lesson is on using joins using the on clause. Just as a reminder, I showed you how to use the using clause to join tables together. This essentially says that the pub ID values need to be joined where they are equal on a row in the book table and a row in the publisher table. But let's go ahead and rework this and do this as if we were using the on clause and we're a bit more specific. So I'll go ahead and copy in the statement just below here. You can see that it starts out the same, publisher, join book, and then I skipped a line, which is perfectly fine. I could have done that with this as well. And I said on publisher, and I put a period there. We often just say dot, publisher dot pub ID equals book dot pub ID. So this is the same statement. It's the same effect as this statement. Using pub ID is really short. It's a shorthand version of on the publisher ID in the publisher table equals the publisher ID in the book table. This is called qualifying the column name with a table name. So I qualified pub ID with publisher. I'll go ahead and run that so you can see it work. And you see we get a very similar thing. We get 5 books for this publisher and then 6 here and 5 here. Let's take a look now at something else. Here's something conceptual that I want to discuss with you. When the data you wish to match is in different column names, well, then you're going to have to use the on clause. There's no way around it. A well-designed database usually uses the same column names in different tables because we can qualify that column name with the table name itself. For example, let's just assume that the pub ID in the publisher table had a longer name. Say they called it publisher ID instead of pub ID. You still could join the tables, but you would do it like this. You would say publisher join book and then on publisher ID equals pub ID. Notice I no longer had to qualify the column names with their table names because a publisher ID was only found in the publisher table and a pub ID was found in the book table. So you can do it this way, but generally a better design uses the same column names. I want to go back to the last statement and I want to show you a bit of a shortcut. There's something called table aliases, which you can say to use a shortcut, an abbreviation for a table name, and then you could use it that way anywhere else in the statement. They're defined on the from clause. So if I say publisher and I put a space and I just put the character P, I'm basically saying where I see P by itself like this or qualifying another column name, understand that that's an abbreviation for publisher. Likewise, join, I'll put space B for book. Now here, in this mythical hookup here, I could have just put P pub ID, and then I put B pub ID. This is a lot easier to write than to having to put out the full table names all the time. And in fact, I think it's a good thing because it makes the statement a bit easier to read. Sometimes table names can be quite long. Sometimes they're much longer than the word publisher. If you have a 30-character publisher name or a table name for publisher, and same thing with the books, what have you, using these aliases, these abbreviation for table names, can be very useful and make statements much easier to read. The general rule about aliases is you can use them if you want to, but you're not required to. Either way is a fine way to go. This lesson is on aggregate functions. Aggregate functions are a way to summarize information in the SQL select statement. So far, all of the select statements you've seen have brought back detailed information on a per row basis. But what if you want to see summary information? These standard aggregate functions can help with that. With SQL and MySQL, we have these functions. We have the sum function, which will sum up or total the values in a specified column for all the rows in the result set. Now that's important because we can make the result set somewhat smaller than the table by putting where criteria in there, and that would reduce the size of the result set. But it will sum up what's left. We have an average function, which will average up the data in the results set. It'll do what you would expect. It would add up all the values and the rows in the results set and then divide them by the number of rows in the results set to give you an average. We have two other functions, the min and max. So these give you a minimum value or a maximum value found in the results set. And this means different things with string, and numerical, and date data. And we'll talk about that in a bit. There's also a count function, which can count all the rows that have a non-null value in the column name. But if we want to get a count of just the number of rows in the result set, we can do a count star or count asterisk, and that gives you just however many rows that came back, regardless of the null status of any column. So let's go ahead and look at some examples here. So I'm going to clear this, and we'll just do a very simple summation. So I'm going to sum up the advance amounts from the book table. So let's click on that. And voila, we get one row back. And that's all an aggregate function, like sum or average or min. They only bring back one row because it's summary information for the entire result set. In this case, the result set is the entire table because I didn't put a where clause on there restricting it in any way. And one thing to note, if I take out the advance here, take out the summary function, and run this again, you notice that we have a null advance value in there. That is just skipped and not counted. And in an average, it wouldn't be counted as well. SQL is smart enough to know how to deal with nulls in that regard without you having to do anything extra. All right, let's look at the average function. Clear it out, put that in, select average, AVG, on the advance. Run it. Again, it's smart enough to know to skip that null value and averaged out. So the average advance we gave for a book was $6,093 and some change there. Now, if I wanted to change this, I could restrict this where advance is greater than 5,000, say. I only wanted to deal with higher end advances. So I could click that and you see we get a different number in here. Now I have a big warning for you. And the warning is you cannot combine detailed information, something that would appear on every row, with summary information in the same statement. For example, if I change this to price, I say, all right, give me the average price. The average price is $28 and something. Now, well, let me see the book. So I'll put the book there. Title, comma, average price. Click on it. It's not allowed to mix detailed information unless you're using a group by clause, which is something we're going to learn about in just a little bit. But you cannot mix the two. MySQL might run it for you. Let me go over and run this in PHP myadmin so you can see what MySQL may do. Let's go to the SQL area again, and I'll paste in that same statement and run it. We get results. It says Silicon Valley startups and an average price. But there are many more books than Silicon Valley startups. So it just gave us one, first one it found or the last one it found. It's basically meaningless. This title doesn't relate to the average price in any way. So whether you get an error or not, you don't want to mix detailed information and summary information. It's incorrect. You cannot rely on the results. So let's take a look at the minimum and maximum features, the aggregate functions. So I'm going to paste in a statement. I'm going to look for the minimum advance and the maximum advance. And I can do this. I can select two summary bits of information, two aggregate functions in a row. I just can't put detailed information. So if we run that, we say the minimum advance was 0. One of the books we didn't give any advance to. And the maximum we gave was $15,000. That's pretty clear when we're dealing with numeric data. But let's see what happens when we deal with non-numeric data, in this case, just text. So I'm going to clear that and bring in a text statement. So now we're going for the minimum last name and the maximum last name from the author table. We run that, and minimum is the lowest on the alphabet. So the first in the alphabet, A, or Adams, is the one that's considered to be the minimum last name. Maximum last name is Suko. Evidently, there's no one after Suko in the alphabet in the author table. One more example, we can actually do this with dates. So I'm going to pull in a statement with dates now, and we'll run it here. Minimum pub date, maximum pub date, the publication date from the book table. We'll click it. The earliest date is the minimum, so that was June 9th, 2012. and the latest date is October 21st, 2012. So we can do the same thing. Obviously, the minimum max works with the different data types, but average and sum only work with numeric data types. The last set of summary functions, or aggregate functions, will be dealing with the count. So I put in here, select count advance. Now it's going to count the number of rows that have a value in advance that is not null. It won't count nulls. So let's run it this way first. Count advance from book. And we see that there's 15 rows that have some value in the advance. Even 0, that counts, but it's not null. If I change advance to star, and that just counts the number of results, number of rows that are returned in the result set. So if I count star from book, watch what happens. I click it, and it's now 16, because there are 16 rows in the book table. You, of course, can restrict this. So I can say where last name equals singer. And let's run it now. I get an error. Let's see why. Simple mistake. I shouldn't be looking at the book table. I need to look at the author table. I'd like you to see when we get an error from time to time, how we can troubleshoot that. By looking at the column, it says the column is not there. And why doesn't it know about last name? Because I was looking in the book table instead of the author table. So let's try that again. So now it says 2. And as I recall, there was an Albert Singer and an Ann Singer. So we get a count of 2 rows that have that value in the last name field. This lesson is on single row functions. Unlike the aggregate functions, which dealt with summary data, single row functions operate on one row at a time. This is one of the main areas where different brands of SQL, if you will, differ. Oracle is different than MySQL, is different than Microsoft SQL. Often in these single row functions, the syntax is often a little bit different. There's a little bit of different set of functions that are available. Let's take a look at a simple one. Paste this in here, and it is the lower function. And it takes text that's found in the database, and it puts it in a lower case. We'll see it in its original case. We'll see it lowered, and we can use the upper function to see it all uppercase. So if I run this statement, that's the way it appears in the data, and now all lowercase and all uppercase. Now remember, these functions in a select statement, at least, they don't change anything. They're just showing us what it would look like if it were all uppercase. If we wanted to change something, we would need to use the upper in an update statement and force the issue to change the city from its regular view to an upper view, if that's what we wanted. Now there's 3 broad categories of single row functions. These are ones that deal with text, like the upper and lower. There's some that deal with numeric data, and some that deal with date data. And you can see this is a row by row thing because every row is what's changed. And as always, I could stick a where clause on here and I could restrict the number of rows that I'm viewing where I ran the lower or upper function on them. Let's take a look at another command. First, I'm going to show the author data, just all of it, for a second, because there is an author who has a last name in the view that I have now called Del Castillo. But there are other authors that begin with D. If I wanted to find an author that began with D, I could do this. I could say where last name like and begins with D. You notice it shows a lowercase d there, but MySQL is not case sensitive by default. So it'll find an uppercase D or a lowercase d. The like operator is used with pattern matching, something we're going to cover in another lesson in more depth. So this says find one that begins with a D, and the percent sign after there just means we don't care what comes after it. It could be anything. Let's run that, and you can see it found the Dingy, Dunhill, and Del Castillo. But if I wanted to force the issue and only see this small d that was stored, I could put the keyword here. I put binary. Now it forces it to look in a case-sensitive way. So I click the button again, and now I only find Del Castillo. Moving on to another useful function, it's the substring function. So I'm going to see the phone number here in full, but over here, after a comma, I want substring. Look at the phone and give me, starting with the first position and for a length of 3. So essentially it's the area codes. I want to see that. So let's see how that operates.
So I see the whole phone number, and here I just see the area code. Of course, I could have put a heading on here so this would say area code if I wanted to really make a report from this, but you can see it lines up with just the first three. Let's look at another command. This is something I alluded to earlier, a way to display data in a single column, and we can use the concat function for this. So I say concat, that stands short for concatenate, which is another way of appending data. It's a big fancy word for appending data. So I say take the city column, comma, and then because this is in quotes, add a comma space, comma, then add whatever's in the state column. So this should give us city, comma, state values for all the authors. Let's go ahead and run this. And you see St. George, Utah, Chicago, Illinois. So it looks in a more normal format. It's not all lined up in each individual separate column. It looks like a normal way we would see Oakland, California, city and state. I just showed you a few string functions, but there are a whole bunch. This is essentially the MySQL manual online. I have put this URL in the working file, so you can find it there, and you can find a list of all these different kinds of string functions. String, if you don't know, is another word for text. So it's textual-based functions. So there's a whole bunch of them there. We're going to move on to numeric functions. Clear this. A common thing to do is to round a number. Select title, price. We can round price to no decimals. So let's run this. And we can see here, instead of 40 decimal decimal, I get 40. Here I rounded, and I rounded up to 30. 41.59 rounds up to 42. It's a simple way to do that. You can use something called truncate, and that will take this and it'll chop off the decimal places instead of rounding them. So here you can see 29.99 becomes 29, not 30, because it was chopped off instead of rounded up with mathematical rounding. And I'm going to show you the page for numerical functions. And here it is. And you can see again, there's a whole bunch of numerical functions. So if you need to do things with numerical functions, you come to the MySQL documentation page and read about them there. You can click on an individual one and then read more details about it. Let's move on with some date functions. There's a nice function here called curDate. And there's no columns involved. You just say curDate with a parentheses. And as you see, it gives us the current date. I'm doing this on February 3rd, 2017. This was the pub date that was in the table, but this is just the curDate that's on the database server that's running. This isn't coming from your PC. All right, I want to talk about two really important date functions. The first one is called string to date. That's the way it's spelled, str to date with the underscores. Dates are only stored in one format inside of the database, and you don't have to really think about it. If you pass it in its normal format, that's cool. That's like the date, 4-character date, hyphen, 2-character month, hyphen, 2-character day. And that'll work. Then you don't need a function. But if you need to do something where you change the date and you have the date in a different format, now here I've just typed in 01/2256. But if there was a column of information that had dates in a different format, you could just place the column here. Over here is something called a mask, or it's a pattern mask. It says, I understand that this is a 2-character month. I understand that this is a 2-character day. And see, there's slashes in between. I understand there's slashes. And then with a capital Y, it says, I understand the next thing you're giving me is a 4-character year. So it knows what format to look at, and then this function will store it correctly in its internal format. Let's take a quick look at what that looks like in the database. Cleared that and put that in. Let's take a look at this one ISBN number. You can see it's 2120612. That's the current date format that's in, and that's the native format with those hyphens. Let's go ahead and try the update statement now. I've copied in the update statement, so we're going to change it to be a different date, 1956. I'll run it. So it says it ran it, and then we did the select right after that. And so now the publication date is 1956-01-22. So it took that format and stored it correctly into the publication date format, the natural default format for MySQL. So I want to go over one last function that's very important with dates, and that is the date format function. And its goal is to display a date in a different format than it's stored internally in the database. So I'm going to copy in a statement here. So title, we'll see what the original date looks like in the database.
And then we're going to format that. See, I passed the column name here to the date format. And I say, make it look like this. This is a pattern mask again, but now I want it to look like a capital month in words. I want a space, and then I want the day, comma, I want a comma, and then I want a 4-character year. So let me run this. And you can see 1956 changed to January 22nd, 56, and like this. So I'm getting it to display in the format that I would like to view. This is not how the data is stored in the database. It's actually stored like that. It comes in handy for seeing things in a more preferable format. I mentioned that we do have a bunch of date and time functions here too. This is also on the MySQL site, and there are a ton of them, so you can read that and look for things that might be useful. And I have included the URLs for all of these string, numeric, and date functions. This lesson is on using the group by clause. Now you may recall that when we wanted to see summary information for an entire table, we might have done something like this. Sum up the year-to-date sales from the book table and run it, and we got a single number. But what if we wanted to see this by the type of book? There are different kinds of books, computer books, cooking books, and we wanted to see that number per type. There is something called the group by clause. Let me show you this. Now, if I do this, remember I said this is going to be wrong because we're mixing a single row function and a summary function. It says, no, you can't mix it up. But it says unless you're using a group by. So let's put a group by in there. Group by type. So I'm saying, even though this seems to be a single row thing, sum it up, roll it up by type. Let's run it. So it says type equals business. That's the year-to-date sales for business, for computers, for cooking. It looks like cooking is doing the best right now. Psychology, not so much. We also have this null group here. Generally, we don't want that, but it will display it. Remember how to get rid of nulls is we can use a where clause. So where type is not null. Let's try that. That gets rid of the null group. So we can do it that way. So this gives you summary information on a group. It's a group of types, the various different types we have. It's not summary information on the whole table. If you wanted to get information on the whole table and get information on the subgroups, you need two separate select statements. You cannot mix and match things that are going to bring back irregular results. The summary on the whole table brings back a single row. This kind of summary information brings back 4 in this case, and the detailed information with no summary functions brings back every row in the table. Let's clear this out. Just a reminder here, we can do this still with a join. We very often want to join in SQL. We want to get information displayed from more than one table. So these are simple joins we're doing now. I'm joining the book and the publisher table. So that's the publisher name. So I'm saying, show me the year-to-date sales by publisher. Well, those are in two separate tables, so I have to get it together. Join publisher to book on pub ID and group by the name. And then I order it by one in this case being the name. So let's run it. Here it is. All three of the publishers we have, and who's doing the best. Right now, Bender and Smith seems to be having the most sales. Let's look at another example. So I'm going to show you another mistake. You look at this and you say, I'm going to group by type. And here's type. So that part's good. But I have another column in here that is a per row column, and it's not part of a summary information. So since I didn't include it in the group by, I'm going to probably get an error here. It says there's a non-aggregated column, price, that's in the select list that's not also in your group by. So it needs to be in the group by. So I do that, type price, run it, and now I'm getting counts, the average price, not per business, but per business of $12.99 books. And here, business per $21.95 books. Well, obviously, it's going to be the same thing because we're averaging it up. So why don't we try something else? I'll sum price, give something a little bit different. In this case, the $29.99 books, there's more than one, so the sum is more than the price of just one book. It's doing it, though, per this grouping. It's a grouping of two pieces of information. And that's why we repeat business here 3 times and computer twice and so forth. So you have to be careful of what it is you're summing up. Again, if you want to group by type in one SQL statement and group by type and price in another, you have to do them as separate statements. This lesson is on using the having clause to restrict information that comes by from the group by clause. Let's go ahead and start with a group by, and I'll paste that in here. We run it. I want to get rid of the null group where type is not null. Run it again. And here we can see we have this data about groups. We have an average price, so-and-so. Now let's say I only want to see it where the average price is greater than 25. So I would eliminate this one. We have something here called the having clause. Having, and now I'm going to say average price is greater than 25. Just like the where clause is used to limit the rows that get returned to the result set, the having clause is used to limit the groups that get returned to the result set. So very often the criteria in a having clause is asking a question about summary information. Here's the summary information, average price. I only want where the average price is greater than 25, thus eliminating that group. So I put it like that. Let's run it. And I eliminated that business group. Now you might be tempted to do this. Let's see what happens. I'll take out the having clause. I'll just do it as a where clause, where average price is greater than 25. So I run it and we get an error. It actually says a very funny thing. It says invalid use of group function. So this error message isn't really meaningful to where the problem is. The problem is above here because we are not allowed to put summary criteria in the where clause. That is not allowed at all by SQL. It only asks questions about a row by row basis. So if you want summary information, you've got to go back to using the having clause. Let's plug that in again in the correct way. Average price greater than 25. If I wanted it to be greater than 30, then I would probably be eliminating even more. Just got that one group that's greater than an average price of 30. So that's the gist. The having clause is like a where clause for the groups. You can still use a where, but you can't put summary information in the where clause. This lesson is on many-to-many relationships. You've already seen that we have a one-to-many relationship between the publisher and the books that they publish. One publisher on here, one row in the publisher table, could publish many books. You've seen that some of them publish 5 or 6 books. And we track that by looking at the pub ID, and that's a foreign key to the primary key of pub ID on the publisher table. But in the real world, there are some more complex relationships. Specifically, it's called the many-to-many relationship. Let's take a look at author and books. An author certainly can write more than one book, and a book can be written by more than one author. Essentially, there's a many-to-many relationship. Now, if we just showed the entities and not the table, the entities are the conceptual relationship, we would not have this thing in the middle, and there'd be crow's foot on the author's table and a crow's foot on the book table, indicating a many-to-many relationship. Unfortunately, you cannot implement a many-to-many relationship directly between two tables. The way it's handled is there's a table that comes in between the two tables that have a many-to-many relationship. This table is completely just invented. It's called a resolution table, a bridge table, an association table. I've seen various names for it, but the idea of it is it manages the fact that an author can have many books and a book could have many authors by bringing the primary key of the two associated tables, ISBN from the book and author ID from the author table, bring them both over to this new table, and together they become the primary key. Let's look at a chart for a second. Here is a little bit of a summary of some data, and it shows the condition where one author, an author represented by author ID 173, this is not necessarily the data in the book publisher tables, but this is just to give you the idea. 173, and his name is John Smith. It shows a condition where author 173 could write 3 books. Here's an ISBN number, another ISBN number, and a third. So these are 3 books where the author ID has written a book.
Now, I don't show the book title here, but it doesn't really matter. The ISBN number ensures the uniqueness of a table. Let's go back to the diagram. See, the book has a primary key of its ISBN number. So this kind of idea is what we need to capture in this book author table. We're going to have a relationship where we show that a book can have more than one author as well, but let's just deal with this simple case. Let's look at this conceptually. I'm going to take out this chart and break this down just a little bit farther. So let's look at the author table. Here we have that author 173, who's John Smith. We have another author here, 190, who is Mary Jones. There are several books. Let's just jump down to the book table. 1 Hour Negotiations, Usability, Instilling Courage, and different ISBN numbers, just so you can get the concept. This is a subset of the data. Now, the book author table, which connects the relationship between book and author, could be something like this. We have author 173, who's written this book, and then written this other book as well. We also can have the book from Mary Jones. She's written this book that's represented down here on that table. That shows again that an author can write more than one book. But let's consider the fact that perhaps maybe author 173 also worked on that book with Mary. So we'll put that down, and I'll put 173, and I will take this book and I copy it over here. So now we can see that this book has been repeated twice, the ISBN number on the book author table, and both 190, Mary Jones, and 173, John Smith, have written those books together. So that's a way to capture this. So the author ID can be repeated on here, and the ISBN number can be repeated on this table, but the combination together is the primary key. So we'll never see a duplicate combination value here. This is important to get used to this idea because when we implement the database, when tables are actually built, again, going back to the diagram, we have to implement it using only one-to-many relationships. So each associated table, author and book, have a one-to-many relationship to this book author table. So that's the way it has to be done. I'm just giving you this little course to give you the concept of why databases are constructed and put out this way. It handles that many-to-many relationship. Even if you're not developing a database yourself, if you're just using one with SQL, understanding why these things exist and what the theory is behind it can help you understand how to join information back together. We're going to be going over how to get information about an author and the books they've written together. And that's going to imply we have to do a 3-table join. We have to join author to book author, and then book author to book to get all that information together so we can present it as the results of a single select statement. Let's show you one other thing that's really interesting. We made up this table, this book author, just to resolve the one-to-many relationship between book and author. But there happens to be characteristics about this relationship that only can be true for the book author table. Let's look at this column. This is called author order, and this represents where an author appears on the book. If something is written by John Smith and Mary Jones, in that order, let's go back to the table here. So if we added this as a relationship in this book here between Mary and John, author order value would be 1 for him and 2 for Mary, if that was the author order column. If it was reversed, Mary would be number 1 and John would be number 2. So that can't go back in the author table. Let's go back to the author table. I can't put author order per author because someone might be number 1 on one book and number 3 on another. So the author order only makes sense in a relationship between the author ID and ISBN together. What order were you on this particular book? And it can't go with the book because the book has more than one author. So you can't just put author order down there. Which author? You have to know which one. So there's a value on author order for each author on that book. The same thing here too with royalty share. It might be a 50-50 arrangement, but if I wrote a book with Bill Gates, you can be assured he'd probably get 99% of the royalties and I'd get 1%. The royalty share is different depending on the relationship between the authors that are on a book. It might not be equal. So we can only capture that as an attribute of this resolution table, of this table that's used to resolve the relationship between author and book. This lesson is on joining multiple tables with the using clause. We've seen already that we've done a simple two-table join. We join the publisher to the book table with a one-to-many relationship. And I've discussed that the author and the book are related by a many-to-many relationship and are connected by this resolution table between them that has the primary keys of both associated tables. So now we have to get all this information together if we want to display in one statement some information about authors and their books, or books and their authors. We're going to have to do what's called a three-table join to do that. This has to join to that, and that has to join to that. So let's see how this is done. Here is a typical three-table join. I'm selecting title from the book table, last name and first name from the author table. Now these columns don't need to be qualified with the table names because they're not repeated on any of the tables. Last and first name are only in the author table, and the title is only in the book table, so it won't get confused. It knows what to do. So here in the from clause, I've broke the from clause up into 3 lines. So I say the first table, from book. Now I'm going to join that with a join keyword to the book author table using the ISBN. Looking back at the diagram, the book table has an ISBN and the book author table has the ISBN, so they can join. Now, the book author table joins the author table using the author ID. Look at the chart. The book author uses the author ID and it joins to the primary key of the author in the author table. This, fortunately, is a nice way to do this. You just chain the statements this way, and it works. So let's see what we get. I did an order by. I could have specified the column names, but when we're working interactively, remember that 1, 2, 3 is what the order should appear in. So let's run this statement. And so here we have the books are all in alphabetical order, and then we have the last name and the first name. Analyzing the Obsessive by John Black. But look at this one here. We have 2 lines with dealing with behavior problems in the workplace. That's because it has 2 authors, Linda Carson and Spencer McDouglas. They are both authors on this book. Same with Fresh and Easy. Gluten Free or Die has 3 authors. This information, just to remind you, has to be repeated so we get a regular grid returned to us from the results of a select statement. If we needed fancier formatting, we could write a custom application with a programming language like PHP, or we could use a software like Crystal Reports or ReportSmith, one of these SQL reporting tools that work well with SQL and allow you to format things in a nicer way. But this is how straight MySQL works, or any SQL really. Okay, so you can see that we got all the books and their authors. So it says 23. Well, that makes sense. Let's go back up and try another statement. Here, I'm actually going to use the same statement. I'm just going to expand on it. Add to this the author order and royalty share. As I pointed out previously, the author order is a property of this resolution table between author and book, as is the royalty share. So let's take a look at that and see what the data looks like. So we run it again, and it's the same idea. Books that obviously have one author, obviously the author number would be 1. But here, Linda Carson and Spencer is author 1 or 2. And Linda gets 75% and Spencer only gets 25%. So you can see this relationship changes depending on the book. Here with 3 authors, we've got 30%, 30%, and 40% for Gluten Free or Die, the 3 authors there. You can see how this plays out about the relationship between book and author. All right, let's look at something else here. You are not limited to 3 tables. You can join as many tables as makes sense to join. So let's clear this. I'm going to show you a 4-table join. This is going to join the publisher to the book author, to the author. And we're using that primary key, foreign key relationship in this case. That isn't necessarily required to join using primary and foreign keys. It's just the most likely join that you'll do. So let's take a look. First, I'm going to go over to the database diagram again. So publisher joins to book using pub ID. Book joins to book author using ISBN. Book author joins to author using author ID. So we can chain this all that way. So book using pub ID, book to book author using ISBN, author to book author using author ID. Now I've added a where clause, and you can do that. I don't want to see this relationship for everybody. I only want to see this for all Techo books. Now in this case, the name is almost a little superfluous because I should only get one. Let's go ahead and run the statement. But we can see we have all Techo books, the titles, and the authors. Now, I know that All Techo Books only writes 5 or 6 books, so why is this repeated with the results of 8? You're going to get repeats often when you do joining. The data itself in the tables isn't repeated, but it has to be repeated in the presentation. Like here, I have to list the publisher twice for this book because it has 2 authors, and it's the only way I can represent the results from a SQL statement. It has to be a regular grid, and so it'll preserve that. So don't think that All Techo Books is doing more than 5 books. This lesson is on joining multiple tables using the ON clause. I've rewritten the statement I used in a previous lesson where I used the using clause, and I've changed them to be on clause instead. So notice I'm using table aliases. I have book B, book author BA. You're not restricted to just one character, so BA is now the shortcut for book author table, and the author table has been described with an abbreviation of just A. So instead of saying using ISBN, I say on B, or book table ISBN, joins where it's equal to the book author ISBN. Likewise, the book author joins to the author table where the book author author ID equals the author author ID. So let's go ahead and run this, and you can see we get the same basic results that we got before. That's the concept. You can use ONs. But I want to show you one other little cool thing you can do where you can join on more than one column at a time. Clear the data, and I'm going to paste in this statement. Let's go ahead and add some information. First name, I'm going to get information from the author table and from the book table. And I'll just take out the social security number. So what this is doing is it's looking at the author table A, publisher table B, and it's joining on where the author city equals the publisher city and the author state equals the publisher state. And you're thinking, wait a minute, those aren't primary and foreign keys. Let's go ahead and look at the database diagram. Theoretically, I could go from publisher, connect to book, from book, connect to book author, from book author, connect to author, but I don't have to. SQL doesn't require me to do that. So if I say I have a city-state column here and a city-state column here in the author table, I can join these tables directly. I do that if it makes sense, if it's answering the question I want to ask. In this case, I'm looking where authors live in the city and state of one of the publishers. Let's go ahead and run this. See what the error is. It says unknown column title in field list. That's because I put title in there and we don't have that in the author or the publisher table. So I'm going to change that to name. Name is what goes in the publisher table, and we'll run this again. Here's name. So we're seeing we have this author at Sunshine Publishers, lives in Berkeley. This author, Sunshine Publishers, Berkeley. Now, do we know for sure that Sunshine Publishers is the one publishing Abraham Adams? No, we do not. Because this just asked the question of an author who lived in one of the cities and states that one of the publishers lived in. So it might not be true that Abraham Adams is writing a book that connects to Sunshine Publishers. So just be aware of that when you do these out of primary foreign key joins. Make sure you're asking the right question and you're getting the information that you really need. This lesson is on eliminating duplicate rows from the results. So let's look at it, just a regular select statement here first. This is just looking at the states. I'm interested in the states where my authors live. So I click on that and I can see I've got a bunch of authors that live in California and then Illinois, Kansas, some other states. So that's interesting. But say I'm just interested in the states. So I'm going to take out the last name and first name. And I'm going to get an error on this statement, but I want you to see it. I click that, and there's an error. It says unknown, column 2. I took out those 2 columns there, and now I have an order by 2 and 3 that are no longer there. So for this statement to run, I have to just say order by 1 if I'm going to do it that way. Submit it again. Here, you see I've got duplicate information, but I'm not even doing a join. That's because I only asked to see the state. And the state value, of course, is repeated for every author. Well, this won't do it all. Imagine if I had an author table that had a couple thousand authors in it. This would be pretty unwieldy and hard to read. So if I really wanted to see just the unique states that were there, I use something called distinct. Put in the word here before the select list. The select list, of course, is the column or columns that appear after the select statement and before the from. So I say distinct, and now I run this again. And now it just shows us the distinct states that are referred to in our database. We have no sense here on what the count is. We could get that, of course, by using the group by with a count. So let me show you first just the count. I can say count, the count function, and within the parentheses, I say count up the distinct states that were here. So it looks like we should have 8. So now I run the statement again, and it says, yes, you have authors who live in 8 different states. Of course, if I wanted to combine this information, I can't just do this. I can't do it that way because this is detailed information with summary information. So when you need groups of summary information, we have to use the group by clause. So let's give this a whirl. So I say from author, and I'll say group by state. When I do that, the group by kind of acts as a inferred distinct because I'm already rolling it up by state. So I'm only going to get the distinct states. Let's see if this works for us. And here we are. So we have California 1 count distinct state. This was a mistake. I need to take out the distinct here as well because we have the group by. Let's run this again. And now we see, 15 authors in California, 2 in Utah, and the other states just have 1. So our group by helps us again. And remember that the group by kind of does a distinct for us. So let's look at one other thing here. I'm going to go ahead and clear this out. I'm going to get the distinct price from books. I run this and we get the various kinds of prices. Plus we see the null group. There's one with nulls. But kind of like with a group by, if I say, oh, I want to see the distinct price and advance, and I run it, the other one got 9 rows. I run this, and now I've got 15 rows because I'm looking price and advance as a separate grouping, and we're putting them together. The price and advance would have to be the same to appear in their own special grouping. So be careful when you do this distinct. The distinct refers to every item in the select list, not just one. So you don't get distinct price. You are really getting conceptually, it's as if these were in parentheses. It's the whole row. So all the information is considered in deciding whether it's distinct or not. And that's why we repeat 1299 here twice because we have different advances to go with it. This lesson is on using the like operator for pattern matching. Now, this is something SQL can do for you. We don't have to just look for something equal to something else or greater than. We can look for some similar patterns. There's some basic pattern matching that is in SQL. Let's look at this very simple statement. We're getting last name and first name from author, but I only want to see where the last names begin with an S. Remember, MySQL is case insensitive, so it doesn't care if it's a capital or a lowercase. What this basically says is I want a word that starts with S, and the percent sign is a wildcard character. That means I don't care what comes after it. Could be nothing, could be 40 characters of whatever. Just anything that begins with S. Now, when you do this, you don't use the equal sign. You must use the like operator. That tells the SQL statement that it could be looking for a pattern. If you use equal sign, it'll look literally for S% and it won't find it. So let's go ahead and run this. So there we go. It was Singer, Singer, Smith, Straight, Suko. So those are the 5 authors we have in the author table whose last name begins with an S. Let's make a little change here now. Let's take this percent sign and let's move it in front of the S. So what this essentially says is look at this pattern. I don't care what comes in front of an S, but the S has to be the last character in the word. It could be anything before. It could be nothing, or it could be 40, 50 characters. Doesn't matter. That's what this wildcard character means. So let's go ahead and run this. We have atoms. There's an S. and McDouglas, because we're looking at the last name. So those are the only two authors whose last name ends in S. And again, you notice this is case insensitive. Even though I specified a capital S here, it found all the lowercase s's as well. Also, this percent sign, it acts a little bit like an asterisk would in Windows when you're doing a find in Windows operating system, for those that are familiar with that. Let's put a percent sign after the S as well. So it says, give me anything in front of the S, including nothing, and anything after an S, including nothing. So let's go ahead and submit this and see what happens. So now I've got a bunch more. What this basically says is an S has to be contained somewhere in the last name. Adams, there's an S, there's an S, Carson. So everywhere we've got an S, whether it's at the beginning, the end, or in the middle, we get a return. So that's a contains kind of symbol. Suppose you want to define a specific pattern or a specific pattern in a certain place, not just contains anywhere, but I want it in a particular place. Let me copy in another statement here. And this one doesn't do that. This one just says find 836 in the phone number somewhere. Go ahead and run this, and I get 836 that appears in these positions. But if I had had an 836 somewhere else in the number, those would have been returned as well. If I want to ensure that I only look for 836 four spaces in, see, because there's 415 and there's a space after it. So I have to have four characters of anything, and then I look for 836. So what I do is I'm going to replace this percent sign with four underscores. 1, 2, 3, 4. It's hard to see here because they all run together, so I counted it out for you. I'll run that now. I get the same results. Let's go look at the author table and we'll see if we even have another pattern. I'll take that off, run it. We'll see where we get some duplicates here. Let's look for a 1 in the second character. That'll be the second character of the area code. So let's do that. So let's take this out, and I'm just going to put one underscore in. I'm going to put 1. Then I leave the percent sign because I don't care what comes after it. I just want to make sure there's a 1 in the second character. So let's run that. And there we are. Second digit here is on the area codes. I have a 1. Those are the two wildcard characters you can use. Single space can be anything, or 0, 1, or many spaces can be anything. This lesson is on using an in list in the select statement. Actually, you're going to use it in the where clause. Now, what is an in list? It's a shortcut to prevent you from having to list out too many or conditions in a where clause. Take a look at this statement. I'm looking at the author table and I want to see where the authors are in Illinois, or the authors are in Utah, or the authors are in Michigan. And could you imagine if I had a very large author table where I had authors in all 50 states and I wanted to ask about 7 states, and I have or, it gets kind of unwieldy. So let's run this just so you can see this work. And you see I've got the 2 in Utah, 1 in Illinois, and 1 in Michigan. Fortunately, SQL gives us a shortcut to do this, and it's with using something called an in list. So let's clear this out. I'll bring in another select statement, last name, first name, state, from author, and I say, where's state in Illinois, comma, Utah, comma, Michigan? Basically said where the state is equal to some state in this list. And this is an inferred equality. You can't use pattern matching with an in list. You have to just say, I want it to be this, or I want it to be this, or I want it to be this. And I could make that list very long indeed. In fact, later in class, we're going to learn a way to generate lists using another select statement, something called subqueries. But a very simple in list can be done just like this. Let's go ahead and run it. And there we go. We've got the same basic thing we had before, Michigan, Illinois, and the 2 authors from Utah. If I decide I want to look for another state, it's as simple as putting another comma, and I say I want the California authors as well. Click the submit button, and now I've got the mix. Now, if I wanted to sort them by state, I'd move state to the left and then just sort in that order. In this case, this is fine. I've eliminated just by those states. This lesson is on how subqueries work in SQL.
As we've seen in the past, we can have an in list to represent state is in California or New York or Oregon. I've changed the data a little bit in the author table, so I'll get results for all three of these. Let's submit it. And we see we have Mark Hall in Oregon, Kurt Dunhill in New York, and a bunch of California authors, as we had before. This list, this thing in the parentheses, it can be generated from another select statement. So we don't have to just have literal results in here. So what I'm going to do is I'm going to take this and just to format it a little bit nicely, I'm going to pull down the beginning and ending parentheses here. And in here, I'm going to put a select statement. And I'll just paste it in here. I'm going to select the distinct state from publisher. You may recall we had 6 or 8 states. I don't recall off the top of my head, but we would get just a list of distinct states. So this, run by itself, would just produce a little list. And so what happens is it produces a list, and then that list becomes what's filled in for the in statement. So let's go ahead and run this first. So we have 16 results, Oregon, New York, and we have these various authors. This is the same results we had before when I was explicit in the in list, when I typed in the values of California, New York, and Oregon. If I were to take this out and just run it by itself, I'll run it here so you can see New York, California, Oregon. I changed the date in the publisher, so it'd be these 3 states. This would make it work out. But here's the thing. If I change the data in the publisher table, I'll go over to the PHP MyAdmin and we'll do this. I've got 3 publishers here just to show you how to add a row here. You go up to the Insert tab, click Insert, and then we'll put some information. So I'll say pub ID for far out books. We'll give them 1, 2, 3, whatever. And the city will be Seattle, Washington. So I'll go ahead and do that, and that'll add a book. Let's go ahead and browse it. And you can see that we've now got far out books here. So we've now got Washington here as well. So if I go back here and so we've added Washington as a state. I'm not sure if we have an author in Washington, so we can go back and change that so we get some results. So I click on author, and I'll take one of these California authors. I'll edit that, and I'll just change it to Oakland, Washington. I'm not sure if there is an Oakland, Washington, but for our purposes, there is now. So let's go back. We're going to take that statement that I did before with the subquery that does select distinct state from publisher and see if we get different results. We should get results for the Washington author as well. So I do it, and here we go, Spencer McDouglas in Washington. So merely by having the data change for the publisher, the results from the select statement change because if I add or delete rows from the publisher, we get different results down here since this list is generated. Now, like mathematics, the thing between the parentheses is run first. So this list is generated first, and then it's just like we typed it in after an in list. Now, I want to show you a couple of mistakes because they're easy mistakes to make, and this is a good thing to be on guard for. So let's clear this out. I'm going to paste in this statement. Now, what's wrong with this is inside here, we are bringing back a list of states. That's cool. But in the where clause of the outer select, I'm looking for city. I'm looking for where the city is in a list of states. Now, SQL doesn't care that I'm doing something that's probably not useful. It says, well, this data is string data, it's text data, and this is text data, and I'll go ahead and try to match it. So let me submit this, and we get no results because there are no cities that have the same name as states here. Now, if we did New York, New York, maybe we'd get a hit, but state isn't a state code, so even that wouldn't work. So be careful that you're matching like things. This column should be returned from the inner select statement as well. So let me show you one other mistake that a lot of people make. And I'm going to clear that and copy this in. I'm looking for states, but they put more than one thing getting returned from the inner select. And it can't match to 2 things. It can only match to 1 thing. When you specify 1 thing here, 1 thing works. So let's run this and see what happens. We get an error. It says operand should contain 1 column. That's this. In this case, we should only have 1 column. We're looking for 1 column. That's all we can get. This lesson is on using the in list with the subqueries.
We've already seen this a little bit, but I'm going to show you some more complexity and some of the little quirks of this. So look what I've got up here. I've got select last name, first name, and then I've got some text here. It just says wrote more than one book. That's interesting. How come I don't put a count or something up there and use group by? Well, because what happens here is from the select list, I'm bringing back the distinct author IDs from book author table. And I am grouping by author ID, which I don't really technically have to use the distinct. I'm sort of in the habit of using it, but the group by will do an implied distinct as well. Go ahead and take that out. Group by author ID having a count greater than 1. So what does that mean? That means that I've got an author in the book author table that's written more than one book. So I want to see the list of those who wrote more than one book. So I'll submit it. And then we can see I've got a list of 6 authors here, it looks like, that have written more than one book. Now, if we look at the internal statement, just to get a warm fuzzy, I'm going to clear this, and then I'll paste in this statement. This was the inner select author ID from group by authors. I click it, and I get these 6 authors. So it makes sense. I had a list of author IDs, and I found them in the sub-select, and then I used the outer select to get them. So go back here, and I've got the 6 authors who've written more than one book. Let's move on. Clear this out and put this in. So this is an interesting thing here with a subquery. I can bring back information from a table, the book, and I'm bringing back a distinct price. And then I can use that information in an outer select or upper select here from the same table. So I'm using data about the table to get data about the same table. So what I'm looking for here is I'm getting the distinct price or prices for however many books equal or begin with the word how. That could be 0, that could be 1, that could be 20, whatever we have. I don't know. That's sort of the beauty of this is it's going to get whatever's true at the moment this runs. So why don't we go ahead and take a quick look at just running that by itself. Clear that, then we'll paste that in, we run it, and we get $29.99. Okay, let's go ahead and see how many books I really have. After running the book, I only have one book with $29.99 that begins with how. Let's bring back the original statement now that we've seen what the inner query does, and run this. Wait a minute. I've got 5 books. How is that possible? I said there was one book that begins with how, and its price is $29.99. Well, once we have that, this whole in list just became $29.99. So we're looking for books that have a price of $29.99. Well, we've got 5 books with that price. I'll bring this up just to make this a little bit easier to read. 5 books that just happen to be the same price as How to Choose a Computer. So we asked a question about this book, How to Choose a Computer, then we use that information to find any other book in the table that was of the same price. I'm going to show you another way to do this with the subquery that's very useful. I'm going to clear this, copy in this statement. So look at this. You can't put summary information in a where clause. I've told you that, and I've illustrated that you cannot say where price is greater than average price. But in a subquery, you can. So here I say, return the average price in the book table. And now I want you to find all the books where the price is greater than the average price. So this works. If this were directly into the where clause average price, you'd get an error. So let's go ahead and run the subquery by itself. Clear that out. Paste this in. Go ahead and run this here. So we see the average price is $28.28. So let's bring back the original statement. We'll clear that out, bring that in, and now we run the statement. So look at that. So we know it was $28 and some change. We saw it run. So all of these books are greater than 28 and some change. Those aren't all the books in the table. Some of them are less. I could even change it to less if I wanted to and see what that looks like. So see, we get different books that are less than 22 and some change. So this is very, very handy. It gives us a way to ask a question about summary information in a where clause by putting it in a sub-select. So you can see from this that you not only can use an in list, but you can use an operator. But here's the deal about using an operator instead of an in list. If I change this to equals, of course, we get no results here, okay, if we're looking for average. But one thing I have to be careful about is if I bring back multiple rows, it will not work properly. So if I said select price from book, obviously price equals price isn't terribly useful, but just the idea that this brings back more than one row. So you have to be very careful when you use an equal sign or an operator to only bring back one thing. This lesson is on creating and using views. Views are special database objects that allow you to store a select statement. This select statement is run when you select against the view, and then the results of the select statement are treated as if they were a standalone table. Essentially becomes a virtual table. The nice thing being, once you give something a view name, it becomes like a table name. You can select against the view name as if it were a table. But the data in that virtual table is being generated every time you call or select against a view. It's being created by the select statement that's stored with that view. So let's take a look at the basic syntax. Over here, we have the keyword create and then the keyword view. In between here in square brackets is the or replace. That means it's optional. So at a minimum, you need create, view, and a view name. The or replace will overwrite a view if it already exists. So if you're changing a view, changing something that's stored about it, it'll simply overwrite it. This is different than with a table. A table needs to be dropped from the database before you can create it again with that same name. Let's look. Create view. View name. It's just like a table name, but it's a view. And here are column names that you can use to override the default column names that would come back from the select statement. For instance, if we selected from the author table and you didn't want the author ID to be called the author ID and you wanted it to be called author identification number, you could specify the thing to override that name. So when you selected against the view name, you would use the newly defined columns. Now this is going to be a lot easier to see by example. So let's go to our first example. Let me clear that and paste in the statement. First, there's the view statement. Create or replace view, and then I made up something called editor underscore info. It was just a name I made up. And I'm not overriding any of the column names, so I don't have to put that in there in this case. So I say as, and then I store the select statement. So select the last name, first name, phone, and editor position from editor. Once I've created that and it's successful, that's all I'll see is you successfully created it. But if I want to see the data that's now considered to be part of the view, I'm going to select everything from editor info. It looks essentially like a table name. So let's go ahead and run these two statements. So here you can see create or replace. This was all successful over here. But now we do select star from editor info and we see these 6 lines. Here's the deal. I see all the lines from the editor table, but I'm seeing less than is in the editor table. Let's go back and look at the database diagram for a second. See, in the editor table, I have editor ID, SSN, phone, position, salary. I have all that. Concentrate on the salary column for a second, and let's go back to the window. I created a view that did not have the salary column in it. And that brings us to one of the reasons we might create a view, and that is for security reasons. We can have that editor table and we can apply security to it that said, I only want people in, say, the payroll department to look at that table completely. Then I can create an editor info view that will only show these 4 columns. These columns are not secure. So I can give the access to the view to more people. Now, we're not covering how to apply security here in this course, but security can be given on a table or a table column basis as needed to various people in an organization. So being aware of that, that's one of the reasons you might want to create a view. The other reason is to hide complexity. And you can hide complexity and give a view name to somebody that perhaps knows a little bit of SQL, but not as much as you do. They're comfortable selecting from a single table, but they're not comfortable making a 3-table join, as you will be. So you provide them with a simplified view that has all the information in it they need, and a simple select can be done against that view. Let's take a look at that. Go up here and we'll clear this all out. I'll paste this in. So we're going to create a replace view, and this view name is called Books and Authors. You remember from the diagram that books and author information are kept in separate tables, and the relationship in a third table that bridges between them. But if we want to get this all together in one place, we create a Books and Authors view, and now I do a three-table join as the stored select statement. I've got the title of the book, last name, and first name from book, joining to book author using ISBN, and then joining to author using the author ID. And once that's created or replaced, I'm going to select everything from the books and author view. Notice I don't have to name the view with the word view or not, but you can if that makes it clearer for you. I could say books and authors view in the name if that were clear. So let's go ahead and run this. Here we are. So I've got title, last name, I've got the author, title, title, author, so forth. If I wanted to make this a little easier to read, I could use an order by statement in the statement itself. Order by, and I'll do 1, 2, 3. And I'll be more specific. I'll actually put the column names there instead of just a star. Now, I'm sure I've got things in order. It's an order by title. You can see the two books here dealing with behavior problems and the order. And we saw this before when we did the three-table join, because the fact is, here, we're doing the three-table join. We just stored it under another name. Look at this simple select statement. Just give me the title and the name of the authors from this view, and it just spits it out for us. So this is a much simpler select statement to have to construct. Now, we don't want to store data like this permanently in our database. It becomes hard to maintain. So we store it in the three tables the way we have it, but we create a view to simplify the process of gaining access to that data. Now, one note here is do not store or don't try to store an order by with the select statement of a view. You have to do the order by when you do the select statement against the view. One last example. Here I'm going to override the column names. I have create or replace view, books and authors, book, last name, first name. Instead of calling it title, I'm calling it book. Instead of last name, it's last N. So I gave different column names in the view for the same things that are paralleled here. And then I do a select on those column names, and I order by those column names. Let's try this. And you can see it's book, last N, first N, it's the same data. This lesson is on combining the results of one or more select statements. Let me go ahead and paste an example in here. I can find out who the authors are in the author table by doing select last name, author. I can find out who the editors are by doing last name, first name, editor. But if I want to combine them all together in one big result set, between these two select statements, I use the word union. And then after the whole thing, I put an order by last name, first name. This order by doesn't go with this select statement. It goes with the result set from both of these combined together at large. So let me run this. And you can see I have a whole bunch of names, 27. I know that's more than what's on the authors table. We can also see if we have duplicates. Let's see if we do here. We have Singer, Singer, and March and Straight. Okay, so other than the duplicate last name with Albert and Ann, there won't be duplicate information put on here because there is an implied distinct when you do a union. If there is an author who's also an editor, it'll just show as one row. If you need to see both those results, you say union all. Let's do this again. We go on. We have Mike Lance. So Mike Lance is evidently in the editor table and in the author table. So if it's in both places and you need to see two rows, you do a union all. Otherwise, you get the implied distinct and that extra row is eliminated. Now, say you are looking at this and go, yeah, I don't mind seeing all this, but I want to know where they came from. So I'll do union all. And I want to know whether they're an editor or an author. when I do this, I can't really tell. Remember that you can put a text expression on a table. So I can put the word author here as a bit of text. And on this one, I can put the word editor here. So let's try that and run it. So we see author, author, author. We see Mike as an author and an editor. So we can see where they came from by just manually hard wiring a statement of what table they came from. Now here's the deal on unions. All those select statements that you will see, they have to have the same number of columns. This has got 3 columns. This has got 3 columns in the result set. You can never have anything irregular returned from a select statement. So you have to do something. Let me show you another example. Clear that out, and I'll paste this in. So here I have that author, I put it in the front this time, last name, first name, and editor, last name, first name. But on the editor table, there's something called an editor position, and that doesn't exist on the author table. So I can just put the word null, or I can put a blank if I want, but null probably will work. So let's give this a shot. I'll run that. And it says null, 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 null. And here's the editor positions for people who are editors. And it's sorted it in author edited order because I still have the order 1, 2, 3 to get that. If I wanted to put something other than nulls, I could just put an empty string. Basically, it's a single quote, not even a space, end single quote, and do that. In this case, I got nulls. I'll put a space in there and do it this way. So you can see blanks if you want to see that instead. So that's the idea. Just make sure that they all line up. The number of positions lines up correctly, and you can get some use out of combining. You can do more than 2 select statements. You can do as many as are of practical use to you. You just put a union between each pair. So if I need another one, I put a union after that and then another select statement. This lesson is on legacy SQL techniques. These are things that still work with MySQL, but they're not in vogue anymore. One of the key things is the join. Paste it in there. Select publisher name title from publisher join book using pub ID. That works just beautifully. Get 16 rows. But in the dark ages, 10 or more years ago, we did not have the join keyword to put in the from clause to specify joining criteria. It had to be done another way. Instead of putting it in the from clause, we had to put the joining criteria in the where clause. So we said from publisher, comma, book with a B, P and B for table aliases. So we said where publisher pub ID equals book pub ID. And we do it that way. I run this statement and we get the same thing, 16 rows. Let's look at another. I can restrict it further, put that in here. I have name, title, type, and price from publisher, book, and the same joining criteria. I still can restrict rows in the where clause. So I only want type computer and I only want prices greater than 20. And you can imagine if we had a 3 or 4 table join, we'd have 3 or 4 of these things and then potentially a whole lot of criteria. It can get very hard to read. So submit it. And we have 2 books here that are computer and they're over $20 and they join to the publisher tables. That's how we got the publisher name. So it's much better to put the joining criteria in the from clause and restrict what happens in the where clause to being search criteria to eliminate rows that you don't want. Let's look at another, a somewhat more complicated one. Again, I'll select that and paste over it. Book B, book author BA, author A. That joins the first 2 tables. And we join those 2 tables and we have criteria. So let's run this again. It works. We get this information, but again, it's much easier to take this kind of stuff and put it up in the join with a using from join using criteria. Okay, I want to show you something else. And this has to do with modified operators. So let's put this here. We're used to looking for equivalents with an equal sign, or in this case, with a subselect, we're using an in list. I'm going to show you this, and then I'm going to show you how to do it with a modified operator. This is the normal way. We select distinct pub ID, and we match up to the pub ID in the where clause up above. Let's run this, and we see all 3 publishers, because all 3 publishers have a pub ID in the book table, so we find them in the publisher table. Let's change the in to be equals any. We have an any and all modifier, so I'm going to do the any's first. This is very close, but watch what happens. I select it. Okay, in this case, we get the same thing. It basically says I'm getting all the pub IDs from the book table. And are three of these in the publisher table? They are. Cool. That's great. All right. So that works just like an in list. But if we change this equals to be a greater than, now watch how this changes down here. I run it. Now I've got Binder and Smith, Alteco, and Far Out Books. Remember, I added a fourth publisher along our way here, so we actually have four publishers in the publisher table. But the reason we don't see one of them is because it's looking to see which one is greater than any of these. So it looks at the one that's essentially a minimum and then brings back the ones that are greater than all of that. The minimum here has to do with pub ID, not with the name. We have pub IDs 1, 2, 3, and 4. That's what we needed to do. So if I put the pub ID in here, just so you can see it, we get 2, 3, and 4. This is like going against the min. A better way to do this would be say we're pub ID in min pub ID or greater than min pub ID from book table. And then that would get us what we need. Another one, here I'm going to use the all modifier. Paste that in. Select name publisher where the pub ID is greater than all of the pub IDs in the book table. It's not pub IDs in the publisher table, so in the book table I only have 3, 1, 2, and 3. If it can find a pub ID that's greater than the maximum, that's essentially the max pub ID, I'll bring back a name. So if we run it, we get Far Out Books, which has pub ID number 4. I'll bring it in here so you can see it. Pub ID number 4, and that's greater than all of the ones we found in the book table. These aren't used very much anymore. There's other ways to do it that's less confusing, but you may come across this in your travels. All right, so I've saved the best for last, and these are known in the game as correlated subqueries. So I'm just going to paste in a statement here, and we'll dissect it. Clear this out, put it in here. The way this works is, up until now, we've always looked at the subselect, run it first, brought back some information, and then used it in the outer or upper select. Correlated subqueries don't work that way. They basically are part of a Cartesian product. They look at this, they say, select star for book, where the pub ID in the book table equals the pub ID specified in the from clause above the subselect. That's very confusing. So it does a row by row inspection of the data to see if we have a match and the type equals business. And the way it does it is if I get anything back here, then this where exists is true, but it's existing on a row by row basis. So if the first row exists, we bring back the publisher. If the second one exists, we bring back the publisher. If the third one does not, we don't. Let me run this. And here we've got 2 publishers that pass the test, but there's actually 2 other publishers that do not pass the test. Essentially, this is a convoluted way to say, give me the publishers who publish business books. Using a join or a regular subquery is much easier than what I'm showing you here. But this is a correlated subquery, and there may be some case in your life where you need to use that, and that's the only way to solve a particular problem. And or you may experience this kind of code when you look at somebody else's code in an organization you may work for. So you saw it here first, the correlated subquery. This is just a little wrap up and thank you for taking the course. In military training, they tell you when you give a briefing to tell the people what you're going to tell them, then tell them, then tell them what you told them. So briefly, what we've gone over in this class, I've described to you what is MySQL. And just as importantly, what is a relational database and how you deal with it when you're querying the SQL database or you're creating tables or indexes or views and that sort of thing. So you did learn how to create and remove tables and how to select primary keys to create indexes to get a faster, higher performing query to get things to be more speedy when you interrogate the database with a select statement. We used very small tables in this class. It's just to give you enough to learn, just a 20-row table here and there. But in the real world, tables can be millions of rows of data. And so performance becomes a very important thing. You learned how to change data with an update statement, add it with an insert, and remove it with delete. Also, you learned a whole bunch of ways to select against the table, including just straight selects, to use group bys, to use aggregate functions to summarize data, and some of the mathematical and text expressions that can be used. Also, importantly, how to sort the results. That's very important. SQL does not sort results for you. You have to do it in every select statement if you want a guarantee on how to do it. So we covered how to do comparison operators and logical operators, what a foreign key is, and how, like in this diagram, the foreign keys over here, pub ID, relate to the primary key of another table. When things are in order the way they're supposed to be, tables said to be in third normal form. So we're talking a lot about relational data, and that's what this is. Relations, in case anybody ever asks you in a job interview, are those grids of information that we see. That's called a mathematical relation. It's not about the relationships between the tables or entities. I did cover a little bit with single row functions, which are the thing that's different primarily between MySQL and Oracle and Microsoft SQL. Everybody seems to have their own version of that. Those are areas as you move from different SQLs, you may have to adjust and get the manual and learn how they do it for single row functions. Of course, we got into more complicated joining multiple tables, as well as the simple joins of two table joins. I showed you a little bit about pattern matching and, of course, how subqueries work. And then the all-important views and understanding of legacy techniques. So if you confront something that looks weird to you and you don't code it that way, at least you'll understand how to do it. So where do you go from here? You practice. It's always best to learn by finding something, preferably real world, that needs to be done, and then do it with SQL. It'll make you come back again and again to look things up, review these lessons, look at the manuals online, and figure out what you need to achieve something. I find Google very helpful, as do most people, to sometimes find the answer to a squirrely problem with SQL. But there's nothing beats practice. There's not that much more to learn about this in terms of just doing SQL. If you're a programmer, you can take this stuff and there's ways to put it in a programming language so the SQL's issued from the program and the results are received in the program, and you can manipulate it that way. Other than that, thank you again for taking the class, and we'll see you online.